Hello, everybody. Thank you all for joining early. For those of you that have jumped on ahead of time, appreciate you joining before we formally start the Cloud Security Exchange at the top of the hour at 11 a.m. Eastern Time. So if you haven't already, please do also join us on Slack. We're going to have all of our discussions in the various channels there. So thanks again for joining a little bit early. We will be formally starting in about 10 minutes. Hello, everybody. Thank you for joining early. For those of you that have connected to the stream already, just doing one final check-in here before we formally kick off the event at the top of the hour in about 5 minutes. If you haven't already, please do join us over in Slack as well. And if you're already there, feel free to say hello in the discussion channel. We'll be starting in about 5 minutes at the top of the hour. Hello, everybody. We're ready. We are finally ready to officially kick off the 2023 SANS Cloud Security Exchange. My name is Frank Kim. I will be chairing the event today, and I'm super excited to welcome all of you to our second ever Cloud Security Exchange. Now, we've already got people chiming in from various parts of the world. I've seen, if you're already in Slack, people saying hello from France, from Canada, of course, various parts of the US. If you haven't already, feel free to turn your attention to Slack and just say hello, chime in with where you're joining us from today. So yeah, wherever you may be, good morning to you, good afternoon, good evening. Super excited to have all of you guys here with us today. And before we get to all of these speakers and the amazing lineup that we've got set up, I just want to share a little bit of background, a little bit of history related to cloud and cloud security. And for me personally, it wasn't that long ago that I worked at various companies and they really did not want to move to the cloud at all. And that really wasn't that many years ago. And really, how times have changed now. Every large enterprise, government agencies, every company, large and small, have wholeheartedly moved into the cloud and adopted the cloud for its various benefits. And that is why we are super excited to have today with us representatives, security experts, and practitioners from AWS, from Google Cloud, and Microsoft. Because it turns out that every organization, when I was first learning cloud all of those years ago, to be honest, I was really only learning one specific cloud provider. And we've gotten to the point where every organization of varying sizes is now multi-cloud, either by choice or by chance. By choice, because they've made a specific strategic decision, a business decision, a technical decision to adopt multiple cloud providers, or by chance, by virtue of acquisition, by nature of the fact that there is a business unit in the company that is doing their own thing. So what does that mean for us as security practitioners, as security leaders? Well, it means that now we need to make sure that we and our teams are knowledgeable about all of the different clouds and figure out how to actually go about securing them, using them, configuring them, deploying them in an appropriate manner for our organizations. And that is why, yes, we've got on this virtual stage here, we've got representatives from all of the various cloud providers. Here on the next slide, you can see that we've got Andre Alfred, we've got Anton Chuakin, we've got Mark Reinland from Azure, Google Cloud, and AWS respectively. But also, we've got my colleagues from the SANS Institute, cloud security practitioners on a day-to-day basis that are going to be paired up with the various representatives you see at the very top of this slide from the various cloud providers, sharing with you their experiences, their insights, what works, what hasn't worked, and what you might need to think about in the future to make sure that you've got the appropriate cloud security capabilities, cloud security architecture, appropriate measures in place for defending against the threats to your environment, as well as, what are the changes that might be coming in the future? I'm sure as we move through the sessions today, we're going to hear a little bit about AI, generative AI, something that is on top of many people's minds at this point and how that relates to the cloud as well. And before I move on and talk a little bit about the agenda, glancing back here at Slack, just want to say thank you all for chiming in here. I see people from, oh, wow, we got folks from the UK, we've got somebody from Bahrain, we've got folks from, of course, various US states, Maryland, Washington, Pennsylvania, but oh, Harold, hello from Costa Rica as well. Nice to see you there. All right. So with that, let's go ahead and talk a little bit about the agenda. Today, we have 5 different sessions lined up for you. We've got an amazing set of talks. And you can see here on this slide that we've listed out 3 of the 5 talks. Well, the first 3 talks, you're going to see that the first one is with Anton from Google Cloud, but you notice that each of these talks are paired with another SANS security practitioner. So we've got Anton and Dave, we've got Andre and Ryan from an Azure perspective, and then we've got Mark from an AWS perspective here as well, paired with Ashish. And it's very cool that we got this because hey, you've got, for the first time here on this virtual forum, representatives from all 3 major cloud providers at one event. And here on the next slide, we round out the overall event by having a SANS specific session here, session number 4, all about security myths, missteps in your cloud migration, because it's not all the time where organizations have a green field, they are moving to the cloud with nothing else, no other legacy infrastructure. A lot of times there are some on-premise systems as well. And so there's a bit of a migration that needs to be figured out. And then we're going to go ahead and end the overall session today with a panel discussion with representatives from, well, yes, Google Cloud, Azure, AWS, and from somebody from SANS here as well. So that's the overall agenda. We're going to stick very closely to these various times here because we know that when especially you are remote like this, sometimes things can come up, meetings can come up, calls can come up, and you might have on your calendar already to attend a specific session at a specific time. So we're going to be sticking to this session schedule as we move forward. Now, aside from the content itself, there are a few logistical items that we need to discuss as well. Now, the first one here is a code of conduct, right? And, we can joke and say that the lawyers make us put this up, but it's not actually just the lawyers. And we at SANS, we take this extremely seriously here in terms of making sure that people feel comfortable, that they feel like they can learn in an inclusive environment. And we also remind people, all of you, about this because, well, there's that old New Yorker cartoon that on the internet, no one knows that you're a dog and you've got those dogs behind the keyboard actually typing out messages. Similarly, right, we have found, especially when you've got online channels like this, it's very easy to shoot off a Slack message, a message that could be quickly sent out that could potentially be misconstrued. So please, we encourage you, if you do feel anything inappropriate, please do let us know by reaching out to us either on Slack or via the email that you see here on the slide. Now, that being said, we've got the SANS Slack workspace here available at sansforums.slack.com. I see from all of your messages that many of you are already in Slack, but for those of you that might not be on Slack already, please do go ahead and join us. This is where we will be doing all of our chats, all of our discussions, all of your questions, your hot burning questions that you want to ask various speakers as we move throughout the agenda today. This is the place to do them. And perhaps even more importantly, meet your various attendees as well from different parts of the world. Now, if we talk a little bit more about Slack, once you're connected to Slack, you will see that we've got a number of different channels. Now, when you go to a real world physical event, you go to a conference that's usually in some hotel ballroom or in some conference center and so on. A lot of times it's the hallway track, right, where you meet and mingle and you talk to various folks. It's some of the most valuable interactions that you can have. And so just like you got a hallway in a real world physical conference, well, this is why you got different quote unquote hallways in terms of your various Slack channels that we see here on the slide. And the main channel that we will be using throughout the day is, of course, the 02, the discussion channel here. This is where, again, you can ask questions to all of the different speakers. You can interact with your various attendees. But there's also other channels here in terms of announcements, swapping your LinkedIn profile in terms of that virtual business card swap. But very importantly, you might have noticed that on the presentation view, you've got your graphic recording. We got an extremely talented, skilled artist, Ashton Rodenheiser, who for some time now has been doing graphic recordings of various events and various SANS events. And for the first time, she is doing exactly that for the Cloud Security Exchange. You can see here in Zoom that you've got an example of the types of graphic recordings that she's going to be providing for each of the various talks. That's going to be available in the resources channel here. And then finally, we've got the pets channel here, a little bit of fun if anybody wants to share which pets, right? Any pets that pet photos that you might find extremely fun as well. So main thing here is to have a lot of fun. Make sure that you are in Slack. I see lots of people chiming in here from, again, various parts of the world as well. I'm based here in Oakland, California, the San Francisco Bay Area, broadcasting from my home office. So really look forward to getting to know you guys here a little bit better as we move throughout the entire agenda. All right. With that, you know that we are also presenting via Zoom. If anybody happens to be connected to Zoom, you could add in your questions directly in Zoom as well. We will take those questions and put them into Slack for all of the speakers and the presenters to get to. Now, it very well may be that we might not be able to, in the limited time that we have, get to all of your questions. If you do have some questions, feel free to specifically tag some of the speakers in Slack itself. We will do our best to get to the various questions, but right, there's going to be, I can imagine, given the large number of attendees, I forgot to mention this here, we've got a kind of a record number of people joining this event. We've got 7,000 people that have signed up from different corners of the world to learn all about cloud security. So really want to thank you all, right, for signing up, for joining, taking your valuable time here to join us, and all of the representatives from the different cloud providers as well. Now, we are actually just a couple minutes ahead of schedule here, but I do see our next speakers. I see we've got Anton and Dave here already lined up. So I'm going to go ahead and invite you guys to turn on your cameras and make sure that we get your presentation queued up here and give you a little bit more time. Anton, nice to see you virtually here. All right. And hey, there is Dave here as well. So hey, I know that they're going to introduce themselves, but we've got Anton, who's at Google. He's a senior advisor over at Google. You know, I also know him via his prior life at Gartner as a distinguished analyst. He's a multi-time book author, and he made his way to Google via the Chronicle acquisition, which I know many of us have heard a lot about. And of course, we've got Dave here, who's a very long-time SANS instructor. He's been speaking, teaching, and consulting on both cyber and cloud for as long as, if not longer, than anybody else I know. So Anton, Dave, going to hand it over to you guys.
Perfect. Thank you.
Thanks, Frank. Hey, Anton.
Hello there. It's basically us and 1,000 of our closest friends, right?
Yeah, this is exciting. It's always good to get together and talk shop. And you know, hey, everybody that's joining us. It is very exciting. And Anton and I go way back as well. Anton and I actually go back even before the Gartner days, right? The ancient history days.
That's right.
So long
maybe
ago.
Before cloud? Is it? Can we say before cloud?
Maybe, yeah. Before as a service was a thing. I don't know. Yeah. So, yeah, it's been a long time. But hey, look, here we still are, and we are talking about cloud pretty much all the time, right? So, good stuff. Let me. All right. So, hey, look at that. So here's what's fun, Anton. I don't know when this headshot was taken of you, but I can tell you, mine was quite some time back. And I'm like, look, I'm just going to keep riding this thing as long as I can, right? I'm gonna keep myself about 15 years younger forever via these shots that people keep using of us. But here we are. All right.
Yeah, I mean, mine has glasses, which probably means it predates me doing LASIK. So that means at least a couple of years ago.
Yeah,
at least a couple.
Yeah, there you go. Yeah, well, I've never had hair, basically, so it's harder to tell. But all right, let's do it. All right, let's jump into it. So, as many of you might have seen from the from the title and sort of the lay of the land, Anton and I are all over the place in this discussion, and that's by design. Right? We actually sort of got together and said, hey, what is it we want to talk about today? And saying everything is probably a bit of a stretch, but not too far, right?
It's hard to extract the themes that are truly new every year for cloud. I mean, I think of it like this. Whenever I have a moment to think of a new trend and some amazing deep insight, like in my Gartner days, I realized that default passwords are a bane of our existence. It's a threat from the 1980s. So, I mean, this is like almost like the thought that instantly comes to my mind is like, but default passwords. And I think, oh my God, we are in the 1980s.
Yeah, well, yeah, this is very true. I actually, had the pleasure of forcing my wife to watch the movie Hackers with me not too long ago, and I can't remember exactly when that was from, but a long time ago, right? And that was a central theme throughout the entire movie. And here we are, it's still a major theme, right? So yeah, to your point, some things really just evolve a little bit, and some things, really never change or never go away.
Well, I mean,
And
you shouldn't say never. I mean, this prediction works really well until it doesn't anymore. And I mean, deep in our minds, we know that at some point the authentication password troubles would be over. It's just that the predictions it would be this year are probably, kind of exaggerated. Obviously, us and some other cloud providers and companies are making passwords kind of go away, but it's a long journey. And I think that, sorry, let's talk about the future. I think that the past is, it's the
well, let's do. And I think, we've certainly got a lot of things to share here, but I think I'd like to piggyback on just a moment on Frank's sort of introduction to this, which is, hey, look, pretty much, not maybe every organization, but quite a few are finding themselves in multi-cloud scenarios. Security professionals are coming to the realization that, learning about cloud security, learning proper architecture principles, looking for better and newer ways to do things within the concept of the cloud ecosystem or various cloud ecosystems is no longer sort of a nice to have. It's a need to have, right? Like in terms of skills, in terms of capabilities, if you're not learning about cloud security and you're not looking to evolve, and again, controls and architecture today within the cloud, you're going to be left behind, right? And I really have seen that progressively since I started teaching about cloud at SANS. I'm sure you're seeing that out in the industry too. This is no longer something that people are avoiding. You can't anymore.
I would say that there's one particular story that really changed my mind, blew my mind. It's hard to say, but it's about that exact point. Is kind of occasionally, when you're inside a cloud provider, you tend to lament about how people do lift and shift or replicate their on-premise models. And basically, I run out of the 1990s jokes very, very rapidly by pointing out that a lot of architectures are still replicated from the past. And so once I had a meeting with somebody who is kind of a junior CISO somewhere, and I was kind of about to point out that using the very data center centric on-premise blueprint for moving to a modern cloud environment is unwise, and there are these arguments and reasons to not do it. But he looked at me, and he's a guy with an experience similar to ours in terms of duration. He's a really smart guy. And he said, Anton, we're not using the on-premise blueprints for cloud because we think it's the right call or we think it's the best way. And then he made this dramatic pause. It's because it's the only way we know. At which point, I was like, as they say in all these Buddhist stories, and then he got enlightened. And then I got enlightened, and I thought, okay, so actually, simply, making snide remarks about people who do cloud like it's the 90s, it's occasionally funny for the first 500 times, but then you realize that actually you need to gradually move people from where they are. It's I have a blog somewhere, I'll drop it in the chat later, that talks about the remapping mental models for security leaders. And this is kind of like, I know DMZ, what's DMZ in the cloud? Well, that's a very difficult question because, a cloud native would say, nothing, it's that, just be quiet. There's no DMZ in the cloud. but it's a bad answer for a person who needs the help changing their mind and transferring their perceptions and security ideas and architecture concepts to a cloud realm. And yes, you can say that there are network architecture decisions that achieve outcomes similar to DMZ, but it's a journey. It's not an automatic answer, and it's not just just tell them and they would do it. It's a whole remapping of mental models is what I observe a lot with security leaders.
Well, and we'll sort of finish on this as we move into our first topic du jour. But I think what's happening, what we're seeing. I mean, an event like this, where obviously there's a lot of interest, a lot of people coming to hang out, which is great. But we see it at SANS. I'm sure you see it at Google. And what we're seeing too is that there's much more give and take, not only from the community but from the providers and the very talented technical people that work there to help everyone better understand what it is they're building. And to your point, Anton, I mean, look, a lot of people started with lift and shift. sort of because they had to. That was the thing that got them moving into the cloud in the first place. But it doesn't take long for these organizations to start realizing that there are different ways. There are probably better ways, and we should start thinking about them and moving towards them. But look, everybody's in this journey together, right? Which is pretty much a lead in to the next topic here, which is, hey, look, maybe it can be better in the cloud, right? I think we've ranted about this before. I'm pretty sure we have.
Yeah. I mean, it is better in the cloud, but only is a little harsh. Ultimately, as some of you have read the excellent, actually most excellent blog that our CISO, Phil Venables, have written on this, and it's called 8 Megatrends that Drive Cloud Adoption and Improve Security. But the point is, for me, is not just to point out that there's this cool blog. The point is to say that actually cloud is more secure than most data centers. Going back to my Gartner days, I remember in the beginning of my journey, people would call Gartner and say, hey, how do I make cloud as secure as my data center? Notice the question. And then over the course of the early to late 2010s, that question kind of mostly dried up because people have realized that, well, actually, cloud is more secure than their data centers. But what they need to do is figure out how to use cloud in a way that benefits, that delivers the advantages in security and in business as well. So that means slowly evolving away from lift and shift. And I think that the first thing people see when they open the door and it's cloud, they see shared responsibility. And that's been something that I've occasionally rambled about and talked about and highlighted that the weaknesses of, namely that it was a nice conceptual framework of like, yeah, I'm the cloud provider, I do X, you're a client, you do Y, beautiful pictures, blue, red, I do blue, you do red, and suddenly a one pager explains the whole world. But then you show up in a real world and you realize, okay, threat detection. How do we share responsibility? Who brings the tools? Who tunes them? Who gets the alerts? What do they do with alerts? What do alerts indicate? Who decides what to detect? Long story, which makes the nuance of shared responsibility come up. And then you realize that's really difficult. And this whole clear shared responsibility thing is nowhere near as clear for many cases. Sure, I can pick a clear case. Physical data centers, CSP. The app you just wrote before your morning coffee, you. Actually, even for the second one is we can debate it. But what we observed is that shared responsibility very often breaks. And I'm not, well, obviously I've been blogging for many years, so I almost have a blog to answer every question. But I've written a piece about pointing out problems with shared responsibility. And a lot of them are quite misunderstood by people, like, oh, who does what, who what gets delegated to. So at Google, and also finally, the final clincher was this. Gartner coined this pretty epic line that 99% of cloud breaches are customers' fault. And it's like it's been copied from one Gartner paper to another, and it has very solid backing in fact. So it's like, I think it's the truth. It's in the sense like it's backed by data. But as somebody in our office of the CISO pointed out, and the quote is, it sounds a bit blamey. And it actually kind of is, but how do you change that? So to us, the whole thinking about shared fate is more of a way to transcend shared responsibility. We don't say, hey, you come to our cloud, we take care of everything. No, that is completely impossible. But what is possible is for a cloud provider to take a more active role in customer side of the shared responsibility, like providing elements to build on, blueprints, landing zones, a whole bunch of other things, made us think that we should kind of not point out that shared responsibility is broken. No, point out that shared responsibility is not the answer. It's not like the final answer. Look at this diagram. This is blue, this is brown, or whatever colors people use, and this is CSP, this is client. There's a lot more, and cloud providers build their cloud, so they probably know it, right? And if I build a cloud, not that I personally did it, like if Google builds the cloud, they know the technology behind it, so it's much easier to make certain security decisions. But ultimately, without a customer, it can't be done. So shared fate for us is kind of us trying to be more helpful with things that are on the client side of the shared responsibility. This to me is kind of profound, and it took a bit of explaining, admittedly. I think we trace the origin of this idea to IT operations, when there's a shared fate between kind of developers and operations. But we sort of adopted it for cloud security, where it's the model where, sure, there is shared responsibility, but cloud provider, as the more resourced and more knowledgeable part of cloud, takes more active role in the client side of the model. That's sort of like the simplest short explanation that I can manage in the morning.
Well, so I have three distinct thoughts on all of this, just because we've been along for the ride observing this as well. Number one, and I want to go back to what you said just a moment ago in our sort of introduction, where you mentioned the concept of changing mental models regarding security. I think the notion of shared responsibility, once people grasped it, and at least the construct of that, I think that's what facilitated a shift in mental models for risk management. I do. I think it sort of forced everybody to go, okay, right, we're in this sort of mixed environment. Some things are ours, some things are theirs. The nuance of that, I think, has definitely changed from, okay, look, we're going to build servers in the cloud, right? And people started like this. The servers are our problem, right? I mean, if I deploy a nasty, completely unpatched Windows server in the cloud, that's my problem if it gets breached, right? So people started to grasp this. Where I think the second point is,
to be fair to Microsoft, if you deploy a completely nasty Linux server, the same exact thing would happen.
Yeah. I'm not pick an operating system. I don't care, right? It doesn't matter. But the second piece of this is actually a function of the changing nature of cloud service providers' business models, and you mentioned it and touched on it, which is, hey, look. We're going to start building out services and elements of the fabric that facilitate you getting to minimal trust, that facilitate you getting to more accessible security capabilities. And the minute that you start making use of those as a customer, I think let's be fair, that you build a service, that's your responsibility, right? So I go make use of Google's service X, Y, or Z. I have no stake in the coding of that, the operations of it, the availability of it, the functionality of it that's offered as part of the product, but I'm using it. And so the outcomes of its use are my responsibility and how it, sort of works into my security model. But I'm relying on you as essentially a provider of those security services. And so I think that immediately sort of shifts us into that shared fate strategy. And let's be fair. I mean, if we're being honest here, which we are, cloud, you're not doing this as an altruistic endeavor. It's a business model. Everybody's in here to, better and, do better and more secure business in some way, shape, or form. If you don't have a secure environment, people aren't going to go build things there. So it's a pretty simple equation in that regard. I do think shared fate is that transition that we've needed, right? I think shared responsibility was a good buzz phrase at the beginning to get people changing that mental model. But I think shared fate is ultimately much more of where we're ending up. That's how I see it.
Yes, I think that ultimately drawing longer tables for you do X, I do Y without fully explaining the implications of X and Y for each architecture is going to be more difficult over time. And people will start, as I did in that blog, people would start finding ultimately a lot of joint areas and seams and fringe areas where shared responsibility is nowhere near as clear as I do hardware, you do apps. Or it is a lot more of a journey together. Hence, I ended up falling in love with shared fate, not because my employer made it up, but because it's actually the concept that fits my view of the world.
Well, and so why don't we go ahead and start talking about an area where things immediately get murky. Okay, because I think when you start talking about hard problems to solve, I mean, if we were talking about traditional old school on-premises identity and access management, in a lot of cases, and you know this world just as well as anyone, it would boil down to things like provisioning, deprovisioning, directory services. That was the crux of identity and access management. And all of a sudden, you're in a software-based infrastructure where everything potentially has an identity associated with it, right? And roles and permissions. And I think if there's one place that I've really seen security teams struggle, right? Security architects, security engineers, people that are shifting that mental mindset into the cloud. it's identity and access management. Because they may not have come from that background. This is something that feels new, feels like they're sprawling all over the place. And in many cases they are. What are you seeing out there in terms of people starting to get a handle on this? And what do you bring into the mix from the Google standpoint too?
So I will actually start with a story as well, and a little bit of a revelation of sorts. So when I was at Gartner, I didn't deal with IAM, and I developed a bit of not sure, I shouldn't say a cynical attitude, but I sort of made fun of the IAM team that we had as being the password exchange team. Because I thought I'm doing this cool, amazing stuff, SOC, detection, triaging alerts, doing data security, doing ML, and they just change passwords. And it's like that's the attitude I had, and it obviously was occasionally funny, but ultimately really dumb. And so at some point, I had a chance to talk to a person who led that team, and it was after we both left Gartner. And the conversation is actually encoded in a podcast that I just shared the link to. So it's kind of me admitting on air that I didn't value IAM enough in my past life, and I should apologize for it and basically lower my head and say, I'm sorry, IAM. You really are the thing if you're in the cloud, and I didn't respect you enough in the past 10 years or something. So today I almost went through a complete opposite. That if I talk to teams that do data security, security operations, and they're evolving to cloud, my usual take is, hey, you want to learn cloud? You want to learn this stuff? There's this, you can read this guide, go take this class, blah, blah, blah. But ultimately, if you want one short piece of advice, is learn IAM. And then somebody grabbed me by the lapel and said, Anton, don't say learn IAM. And you know why? Why not? Because you shouldn't just learn IAM. You should learn IAM and keep learning IAM, because in your cloud usage and in cloud provider stacks, identity and access management actually changes. We build features, our friends from other two clouds build features. We see what they do. Occasionally it affects our thinking. They see what we do, it affects their thinking. IAM evolves. It evolves to the needs, to how business uses cloud. So in essence, learn IAM is good advice, but start learning IAM in the cloud, how it works, what terms mean. It's probably the best advice to almost any security professional doing in the cloud. You're in a SOC, you're doing EDR, you're doing some other piece of cloud security or traditional security moving to cloud. You want to invest time in learning IAM. And that whether it applies to things like that Dave would go to, like machine identities, rules, roles, privileges. Another story goes like this. One day, a few months ago, I was reading Azure documentation. Long story why. And I realized that some of the words they use to indicate IAM concepts, I don't even actually know. And I realized, wait a second, not only I don't understand what they're talking about, like even some verbs I don't know the meaning of. I forgot the example. It was actually more than a few months ago, more like a year ago. But I was like, that's a whole world, and it's a world that subtly different between cloud providers. So my former colleagues at Gartner have written a few papers highlighting the differences in IAM thinking and implementation across the big three, which is, of course, big three cloud providers. That's the area that you want to invest your time in if you're in the cloud. It's almost like no qualifiers to this advice. You just do it. I do it. You should do it. Dave has done it, I think. But that's kind of the idea, is that a lot of this is quite central to your future cloud security, no matter how things turn out.
Well, yeah, and I would actually go so far as to say it's table stakes for skill sets. Yes, and while it might seem attractive to say, hey, look, we've got that one person on our team or two people on the team or whatever the size team might be that has deeper expertise, I think you almost can't build cloud infrastructure and understand the security ramifications of interactions and interoperability between services and assets and objects without at least a fundamental understanding of how IAM works within the respective cloud environments that you're in. I think you have to do that. And I know, again, coming from, the old school on-premises mindset, this is that mental model shift once again, the bane of existence. There's these classic things in security that security people just decry and really, kind of rant about. And one of them was service accounts, right? So service accounts are a never good thing. They're always this, Achilles heel for security. And I think, mentally, what I've seen a lot of security professionals do is sort of equate that concept of service accounts to machine identities, right? In other words, non-human identities within the cloud. But I don't think that's really a fair approximation. I really don't. I think the nature of understanding that everything in the cloud has an identity, that's how things are oriented within the cloud and what allows everything to function. You have to just understand the fabric of the cloud is identity in a lot of ways. Everything is hooked into it. And I think that's been a real struggle because people feel like they've lost track of it all.
Yep. And funny enough, the other, I've been dropping more links to the resources channel, but somebody from perhaps a little similar attitude have written a blog that says, I hate IAM, but I need it desperately. And it also reflects the attitudes of a fair number of security professionals that I've met. And to me, the fact that there's a whole world of not just user accounts, but service accounts, machine identities, how they interact. And moreover, to give a little bit of a spoiler of the future discussion, a lot of this must be done right to implement any semblance of zero trust approach, or as Dave likes to minimize it to minimal trust approach. The idea is that without solid IAM understanding, including the machine identities and other accounts, you won't do ZT. ZT won't happen. It wouldn't converge.
Yeah, I think that's fair. And yeah, you can't even philosophize about that with
I can philosophize about anything. How about that?
Well, sure, of course we can. How much time do we have here, right? But no, to be fair, you're never going to get there without identity being a core part of that. And going sort of back to this notion of the shared fate model, what we've seen, and I don't want to speak out of turn for the other representatives of the other members of the big three that are here, because I think they can certainly speak to this themselves. But I have certainly witnessed, as an objective observer coming from SANS and the industry in general, that there has been huge effort made on the part of all cloud providers to facilitate better understanding of identity and to sort of arm not only DevOps and cloud engineering teams, but security teams with some of the tooling needed to not only understand it, but to better lock it down. And so, I mean, this is just some examples coming from the Google Cloud environment. I don't know if you have some thoughts on this, but I'll say that basically, the addition of things like, the Cloud Policy Analyzer, that's a godsend for security teams that are starting to try to figure this out.
Yes, and I think that's also another good example where shared fate shows superiority to classic shared responsibility. The classic, purist shared responsibility would be like this. I'm the cloud provider. I built this amazing IAM tooling. I wrote this incredible 600-page document. Accounts, however, dear client, is your problem. Here, that's shared responsibility. I got the tools. I got the docs. You do you. I mean, that's sure. Yeah, you can do that. But ultimately, in many areas, the area is kind of a mess, and the area requires a lot of help, and it means technical help. You pointed out that the policy analyzer, we have this whole other layer of technology called organizational policy. There is a fair bit of ML and AI type of analytics on the back end, and most of it serves to help the client figure this out or do it, or sometimes hold their hand and say, hey, client, our machine suggests you don't go there. You should probably go over here. It's your call. But based on our knowledge, based on our understanding of your environment, it is better to go to the right rather than to the left. You'd be a lot more secure. And that can be done, that kind of guidance can be done by systems and machines. To me, this is shared fate playing sort of like to its advantage, because we do take a more active role, because ultimately we build the IAM. We know how to use it more securely. We're not forcing anybody. We don't say, no, you can't do that. If this account is locked to this permission, you can't change it, because that would not be enabling the business. That would violate the other principle of ultimately cloud serving the business. But all sorts of nudging and guiding and advising and recommending, like with our IAM recommender, a lot of stuff is done in a shared fate model, and not just like, here are some tools, basically go harm yourself with that, because that's ultimately the bad take. To me, it's our thing. We need to help you use it securely.
Yeah, well, and I think you sort of bring up a good point, which is that the maybe not so subtle suggestion from the backend fabric itself, using things like machine learning and so on, to suggest, hey, maybe you're doing it wrong. You're welcome to continue doing it wrong, but you should consider this option instead, right? That's correct. My not so subtle way of suggesting that. But look, we need that. I think that's the people are building huge, highly complex architectures out in the cloud. It's actually very easy to make mistakes, especially in the early days of deployments across the board. Having that sort of insight and that knowledge base coming from the back end itself, I think is really valuable. And things like landing zones are certainly great examples of this. There's just all these pieces starting to come together. And I think IAM is just a perfect example, as you've mentioned, of shared fate. I really do. I think it's evolving still. I think we're still seeing this evolve progressively to where, maybe this is idealistic, but I'm hoping that in the next 2 to 3 years, IAM is no longer viewed as this source of pain and overt complexity that people dread, right? That's what I'm hoping, is that it gets to that.
Yes, because ultimately in the cloud, we can build it better. We wouldn't be constrained by the 1990s directory models and other stuff. Like we are, okay, Dave's smiling, which is good. I did skip one word, right, in this phrase. So ultimately you can do it better, and you can do it better without being constrained by the legacy.
And that's actually a perfect segue. It's almost like we set it up this way, but this is a place where I think it's easy to do it better in the cloud, period.
Yes.
I really do. Now, look, to be fair, you can also do it terribly. To what we just talked about a moment ago, it's highly possible to go and expose data and objects that are containing the data in the cloud, if that's what you're either trying to do or accidentally doing. But having managed massive scale encryption and data security concepts, models, architectures in an on-premise world, this is a place I feel very comfortable saying it's vastly simpler to build a secure data model in the cloud than not.
Yes, that's sort of like unambiguously so. And it's interesting that the perception that in data security cloud is better has spread a lot faster than say in IAM it's better, but it's a lot more difficult to use. People who are kind of clinging to host security and EDR and endpoint stuff, sure, they're having some trouble when cloud models dissolve it, you get containers, you get other stuff. But for DataSec, you can have perfect knowledge of what your data is in the cloud. You cannot have, oh, sorry, we used production data for testing, because you can have a tool from the cloud provider or from a third party that just tells you, hey, you're doing this, stop doing this. And you can't be like the team XYZ did it, because it's in the same cloud, you can have visibility over data. Now, admittedly, and it's a little caveat in the corner, there would be applications where you want to not have that, and then things like confidential computing, where your data processing and your data is protected even from a cloud provider, is the need. That to me is a kind of a niche case. I really want the better data security, which is provided by the visibility, detection, tagging. But for some use cases, I would say, okay, I will sacrifice all that to shield my data from cloud provider and other tenants, and I would go confidential route. To me, this can overlap, but ultimately for many security requirements, they kind of conflict.
Well, and that's it. Really what it comes down to is, hey, what do you need in order for your organization to satisfactorily have a data security model? Irrespective of wherever it's going to be, what are the key themes and key concepts and key controls that absolutely 100% need to be in place? And then the second question is, once you know those things, are they available to you in the cloud, and what is it going to take for you to enable them? And the answer, invariably is they're all there. All those controls are available. You absolutely have the ability to know what data you're dealing with, where that data is, automated encryption. Just like the whole concept of encryption by default is a beautiful thing in its own right.
Yes,
and we've not been able to say that.
We don't talk about it enough, almost. It's just so painfully obvious when you're here, when you're inside cloud, and it's like, like back in the data center deep stage time, people would be like, hey, Dave, you're a big security consultant. Tell us, should we encrypt every hard drive in our data center? And then people go like, yeah, absolutely. No, 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 it's too costly. Yeah, yeah, absolutely. No, 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 it's too costly. Like this whole, you can argue over that for years, and some people actually did. But in cloud is like, that question is over. It's encrypted. What else do you want to know? Encrypted.
And key management is central and integrated into everything. Wow.
Yeah.
You know, like that alone, I don't know. So to me, that's just a game changer all the way around. But look, I think it's good to have wins, just like flat out, this is a win. It's not a hard thing to discuss. If you really set your mind to it, you can absolutely have better data security in the cloud. There's just no question about it. So
I mean, I want it to be the world where you are guaranteed to have better data security. And this is another thought that comes from our CISO Phil Venables, is he wants some of this to be inevitably secure. Now, somebody with a cynical mind would say, well, isn't that the same as unbreakable? And no, it is not the same as unbreakable. I don't think you can do unbreakable. But you can do inevitably secure to some use cases. You can do it in such a way that customers won't be able to take the riskiest route, or at least they have to jump through a lot of hurdles to take the most risky route. So you can go for inevitably secure, but I don't think you can go for unbreakable. I mean, we've been doing cyber for a good number of decades at this point, and there ain't any unbreakable out there.
I'm pretty sure that there was an attempt to make a movie about Unbreakable, and it had a terrible ending. So yeah, I don't think that we probably want to go there. I'll tell you where we should go though. And we have the advantage, Anton, of being the first presentation today. We are not going to be the last ones to be talking about this. I am 100% sure. But hey, win for us. We're first, so we get to talk about it here.
Yeah, I mean, it's a fun one, and I'll try to make it not very buzzwordy. Ultimately, we do see. I mean, to me, if somebody wakes me up at 3 a.m. and says, Anton, ML, AI, and security, I would still go to kind of 3 pillars. One pillar is securing your use of AI. Pillar 2 is using AI for security. And the third pillar, can you guess what it is? It's, oh, you go and guess then.
Well, I'm actually sitting here thinking, but we don't have enough time for me to think too long.
Okay,
so just go ahead and spit it out.
Countering the malicious use of AI, because it isn't the same as I use AI for business, I need it to be secure. Great, pillar 1. I want this amazing cybersecurity gadget that's AI powered. That's 2. But there's bucket 3, countering the malicious use of AI. Yeah, adversarial use of AI. And this is I had a recent blog from our colleagues from Mandiant about this that highlights some of the things we've seen. But ultimately, this pillar 3 does exist, and it probably isn't something that makes me lose sleep at night. Actually, it's pillar 1 that does, namely secure use of AI. But there are 3 pillars, and I like to think about what goes into what bucket. Security of AI is not necessarily AI powered, because you can, to me, if you have an axe, you can cut the wire. You don't need AI for that. If you have no access, there's no attack from that route. So in that sense, sometimes the security of AI has nothing to do with using AI. But at the same time, there are certain advantages for using ML AI for security. And when this generative AI thing started, a lot of people started saying, hey, I'm the first vendor to do blah. And it's like, and we were kind of standing in the corner saying, do you know that Google had an AI red team for like 8 years, or maybe like 9 years? and there are people here with a decade of experience attacking AI. And it's like, sure, that's what we do. And that's, in many cases, when I had a chat with one of those people, I realized that red teaming AI has almost nothing to do with red teaming. It's a very different craft. I'll drop a link on some of this in a moment. But it's interesting how this is developing new areas of security, almost like there are ways to kind of apply some of the security concepts for AI by learning some of the lessons from other security domains, but also you need to learn AI quite well.
I would almost say, I think that's a really interesting way that you said that, you know, it's not really red teaming. I would almost think of it more as like fuzzing in the realm of bug hunting, right? It's a different sort of, you know, tactic or element. But I want to actually change this quickly and throw it out to you, because we just talked about how things like machine learning and AI are in the background and facilitating better security-oriented decision-making around things like IAM, right? So let's bring it into more of a real-world case. And it's behind the scenes, right? So I'm not interacting with the AI when I'm going and trying to craft IAM policies. I'm relying on Google's AI to basically help me, right? Okay, given that, and given the pillars that you just described, if there's a means by which an attacker can somehow pollute the data models that are in the back end that are driving the decisions for people to make, you know, again, properly crafted IAM policies versus those that are maybe not so good, would you put that into pillar 1 or pillar 3?
I would say that crafting, it actually would be in pillar 2, because it would be security, use of AI for security. Like IAM is an area where a lot of AI techniques are quite helpful, because let's face it, a lot of the policy writing things, you know, humans shouldn't do it. Like we have better things to do. We can, you know, drink coffee or be on the beach or detect or hunt for threats ultimately, or do other things that are kind of connected to cutting edge implementation of other security controls. But writing IAM policies, admittedly, machines can do it, but machines weren't smart enough until recently to do it. So to me, crafting IAM policy, defining them, tying them to what you need, tying them to insider risks, tying them to regulations, that would probably go to machines, whether it's generative AI or other types of AI. That's admittedly where this would be. And moreover, as a kind of a funny aside, yes, I have a funny aside here. Somebody asked me at lunch once, what would be the first security sort of like a task or role or maybe even a job that gets replaced by AI? And they kind of meant it in a more controversial manner, like, hey, who has the most to worry? And I kind of thought long and hard, and I did think about policy writing and IAM as being very, you know, ripe for disruption. I don't think it's detection. I think the attackers would outsmart the machines with the help of their machines. And so humans would be quite needed. But things like IAM writing, where you need to carefully consider a whole bunch of other things and do things just right, that's for the robots.
It's going to be fascinating to watch this evolve.
Yes.
And speaking of evolution, I want to talk a little bit about this cloud security AI workbench. Just
and no, I didn't
briefly,
want it.
because
This is like all Dave slides. This is this slide is like very Dave. It's like not like Anton made him say it.
No. Yeah. So, and by the way, of course, you know, I have to plug the fact that we wrote a paper together, and it's going to talk about all this stuff in a lot more detail. But you know, look, I'm going to call it out. Where cool things are available, people should be you know, aware of said cool things that are now available. And I think this is one of the cooler things I've seen evolve, you know, in recent months. And so it's worth mentioning, you know, I mean, again, Anton did not absolutely force me to put this in here, but I think, you know, so look, I remember, you know, so I don't want to, you know, I'm not going to go into story time. We're getting close to the end here, but I remember very distinctly, you know, kind of scratching my head years ago when Google acquired VirusTotal, right? And just going, okay, wait, why? Right? Like, why would Google want to buy VirusTotal and incorporate that? And eventually I said, well, to you know, probably, you know, build that knowledge base in some way, shape, or form for some, you know, some reason. And I sort of came around to this, you know, I maybe had my light bulb moment when Google acquired Mandiant. And I went, okay, all right. So, like, you know, think about the data sets and the knowledge and introspection that they are coming into this with. And I take that and I'm like, all right, so now you're basically building this catalog of just staggering data about all manner of bad things. And, you know, since we're talking machine learning, since we're talking AI, it looks as though the AI workbench is basically manifesting that knowledge, you know, that behind the scenes knowledge of bad things and all manner of, you know, and all manner of things, into something that's usable by security practitioners. That's what it seems like to me. And I guess I just wanted to get your comment on it. You and I haven't even had a chance to really talk about this too much, but, you know, just looking at sort of what's out there, and you know, this is a pretty cool diagram, actually, not to mention the fact that it is moving, which is amazing. But you know, look, Uh, this is just something that I think we're going to be getting a lot of questions around. Like, okay, well, wait a minute. It goes to all three pillars that you just talked about.
Mm-hmm. Yep. I mean, I would start from saying that we did have to sort of train a lot of models to security. And we actually recorded our podcast with an engineering leader who was involved with this. And he said something about teaching AI security. And I said, but wait a second, we have a policy against anthropomorphizing AI. So you can't teach it anything. It's a machine. And he said, yeah, but everybody knows what I mean. Like if it's a machine learning model and you need to learn security, what you do is you teach it. And it's not the same as you go into a consumer grade online chat bot and saying, hey, what should I do to secure my environment? Like you will get advice for sure, but this advice wouldn't be from learned that bot learned security kind of randomly and not by being trained to do security. And that's why a lot of the underlying models that sit under all this machinery that Dave is showing were trained to know security using Mandiant corpus, using VT corpus, using a bunch of other stuff that's a lot more interesting and also very sizable. So in essence, it's not the advice and the outcomes you would get from these technologies wouldn't be the same as you going to a consumer grade chatbot and asking about security. Moreover, I've encountered somebody who wants the consumer grade chatbot to write code focused on security, and that code would then run in prod. And I was like, you didn't do that, did you? Like, no, that's a little crazy. Like, there's a lot of stuff you can do to sort of explain things, qualify them, classify them, and then eventually produce code that you may run, like maybe run playbooks and other things. But to me, there's a long journey behind using AI for security. Like even the Aristotle example, you can drop a script you found online and say, hey, VT Code Insight, what is the thing? And it would say, it's malicious JavaScript, probably written by this group. That's pure magic. I'm sorry, but like it would be years of reversing experience that would let you do it if you're a human. But for a bot, it would give you, admittedly, a fairly accurate statement that what this code does, and why it's there, and where else it was used, and who probably wrote it. Not who with the last name, first name, but like what group. To me, that's magic, and that is possible with the current forms of AI. And this stuff is. Actually, this is in GA. It's not even beta. I think you can just go and do it.
Yeah. Well, and I look at this and say, okay, hey, I'm trying to write a Sigma rule that's going to be applicable about both, like cloud native and, legacy on-prem models and things. Can this help me given a number of parameters? And I think 100%, absolutely. This is exactly the kind of thing where that knowledge base and the distillation of that into a, uniform format with the machine models that are there. That's amazing. Magic is a pretty good term for that, I think, actually.
Yes.
So, yes. All right, let's wrap up with our thoughts of magic, where things are going, right? So, Anton, I'll open it up to you first. What, all this stuff with we covered a lot in our talk here. I mean, if we're looking forward, and everybody hates predictions, but you see enough of the writing on the wall. What are we going to see in the next year related to all this?
So I would say that I would start from items 2 and 3. I think that given that shared fate approach, given the more active role cloud providers play in security on the client side, I think that IAM bucket of problems and misconfiguration bucket of problems would start to be rapidly reduced. I'm going on a limb saying this because in the past people have said this and it did not happen. But I feel like we are in the position where we built enough of the technology and build enough of the education, evolution, transformation knowledge so that we can tell people that these things would get better, would start getting better fast. I think that focus on IAM, focus on data security, focus on working together with your cloud provider on security would be still quite central in the coming years. And this is a bit of a mundane prediction, but guess what types of predictions have a higher chance of coming true? The ones that are mundane. If you say flying cars in 2 weeks, flying cars next year, probably not. So in this case, I would also say that today, the role of novel models, novel approaches to AI will be transformative in islands. I don't think we'll have, hey, AI, please secure my network, or hey, AI, please make me safe in the cloud. I don't think macro transformation is in the short term, but there would be micro transformed areas where AI really changes the game. If it can turn any human into reverse engineer in 5 minutes, that's changing the game in that case. Again, there are caveats to that, but that's kind of the story. So to me, IAM, misconfigurations, data security, working with cloud provider in a shared fate model, and why the use of AI/ML is what we would see in the coming years.
And I would agree. So, hey, that's all the time we've got. Anton, it's always awesome and fun to hang out. So good seeing you again, my friend.
Perfect. Thanks for
I will
inviting
hand it
me.
back to the team at SANS to transition into our next presentation. Thanks, everybody.
Perfect.
Perfect timing. Thanks a lot, Dave. Thanks a lot, Anton. All right, up next, I'm going to invite Dr. Andre Alfred to go ahead and show his camera, which he's done, as well as Ryan Nicholson. Quick introduction here. Andre is a VP over at Microsoft, Azure Security specifically, had prior lives at Oracle and at Capital One, so a lot of cloud-first experience here. Ryan is the author of the SANS Sec 488 Cloud Security Essentials course and the co-author of the Sec 541 course, all about cloud attacker techniques and monitoring, and also has his own firm, Blue Mountain Cyber. Andre, Ryan, we'll turn it over to you.
All right, thanks a lot, Frank, and thanks for doing my introduction for me. That's how I was going to actually kick this off. So what we're going to, myself and Dr. Alfred are going to talk about today, you can see it on the slide here, navigating cloud security challenges, principles and strategies for cyber defense. We're going to cover 4 overarching principles to help defend your cloud workloads. And I'll warn you, there's going to be a little bit of overlap between this presentation as well as Google. And I actually appreciate that. It seems that a lot of the cloud vendors are having the same concerns. A lot of the customers of these cloud providers are also sharing in some of these concerns as well. So we're going to try to get in front of some of that and raise some awareness on where some of these challenges may be and how to overcome them. So I'll pass it over right now to Dr. Alfred to do a quick introduction of himself as well and actually roll straight.
Yeah. Oh, so Ryan, you muted yourself somehow. But hey, hi, I'm Andre. I want just to, since I did get an introduction, what I'll say is my role in Microsoft is basically to defend the Azure platform. And what is Azure? What's the definition? It's the data center floors, all the OT environments, the network devices, the physical hosts and servers, the racks, the rack managers, all the way up through the Azure Cloud products and services for this division of the company that I'm in. So I have a lot in common with a lot of you on the phone and on YouTube watching today. Whereas, I work with thousands and thousands of people trying to get the right thing happening as far as security posture, right? So, I look forward to this conversation today with Ryan. Ryan, just call me Andre, it's fine. And what Ryan and I decided to do is just talk through some of those challenges. And for our previous panelists, I did take a lot of notes where we do overlap. So, I think we can work through it and it'll be fine. And I can kick us off. Ryan and I decided, like, how can we address this audience that has such a big challenge in their plate to defend their corporate environments around the world. And Microsoft just put out our digital defense report, which we have the benefit of having, what we say is like 65+ trillion signals per day we monitor. You think about the endpoints we have around the world, over 1 billion, and over 1 billion Defender for endpoint customers using Windows day in and day out at home and in the office, plus our major cloud environments. And we do what we can to synthesize that to share with the world on what we see, what's our perspective. And it came out just in time for this. So we leveraged all that content. And I think we'll talk about that, and we'll see how it goes. Ryan,
Yeah. And just diving right into the very first of our 4 principles here, which is really where SANS comes into play, I think, most heavily here. there's definitely always more to learn, especially with cloud. It's not just moving into cloud technology. It's like, oh, another thing I have to learn to defend my corporate environment. It's just that cloud in of itself changes so constantly. It's like I've lost track of how many services each vendor has that we're dealing with here nowadays. And it's not just us as defenders. I mean, attackers are pivoting too. So there's some new functionality out there that they can abuse in some way. We have to know how they're abusing those new functions, those new features. AI, of course, scares the heck out of me, as it may with some others as well, which we'll, of course, talk about that near the end of our talk as well, and how defenders can leverage those types of technologies. Again, something that was brought up in the last presentation as well. So as we talk through these principles, we will also be discussing some common attack techniques that you may see, how to spot those techniques, how to get in front of them, as well as we move forward here, right? So I don't want to speak for Frank, but this is probably why there is a cloud curriculum nowadays. There's just so many moving parts to cloud. There's, of course, defense, there's prevention, detection, incident response, forensics, penetration testing, you name it. It's really grown into a very, very large curriculum. It's not like you can just throw a module into a course and say, I know cloud security now. So there's constantly so much to learn moving forward. And we have to be those forever learners at this point in time. I used to work in environments before. Now, I'm not throwing government workers under the bus, but I will just say that some of the rumors are true. Some folks get into a position, they get really stagnant. It's like they're really hard to get rid of. We can't do that anymore when it comes to cloud, right? We have to stay cutting edge to help the businesses thrive, but also stay in front of the attackers in these spaces, right? So we can't be that, that really stagnant employee anymore. It just doesn't work.
Yeah, I mean, there's so much change going on, right? Like, so like, yes, I have to defend all these new services that show up every day, right? So absolutely. And what I'd say is just some of the mentality as we talk through these of around just this change is constant. Cloud providers should provide great ways to manage that if it is your role to secure your environments. And just that eternal learning, Ryan and I do have a background as well. We learn like nonstop, right? I guess it's a hobby for us. And when you're in cyber, that intellectual curiosity will definitely make you differentiated in your organization, because you can never go too deep or too broad or whatever, right? You can sort of pick whatever you want to learn, and you can make it be an eternal learner just in that one topic. Like I'm a networking guy mostly, right? So just knowing that on the operational side, with the depths are to learn that there's an entire security world there, and particularly with cloud and the fragmentation, interconnectivity between systems, you can go on and on. So our first, so in that case, right, here's what we're presenting. Like still though, I think, Anton spoke before around the password example, right? Hey, we're still just rotating passwords. We have this 98% that we find of basic security hygiene still protects of attacks are against the basics. And one of the things I think, we maybe should discuss is like, why is this? So with all these new tools, techniques, options, things that we can enable, we still have this fundamental hygiene issue. And just, as the person in Microsoft I run governance along with all these other things for all the services. We still maintain a laser focus on that, right? Every week, what's happening every single week. So, we're doing it at our level. And where we know that our customers do. And when I give presentations to customers, they're asking, how do we do it? How do we stay on top of it? And discipline is the answer, right? Like you just have to maintain it. It just does. Like, the reason why that doesn't change over time is because human beings have a scope of that's limited in the ability to adapt to all these changes, right? So we can offer as many new things as we want, but we have to bring everyone along. We have to actually make their jobs easier for them that are trying to develop the next product, push out the next update, build the next thing. And the more complication we add on top of that burden, the more likely it is that we have lapses in just in the basics, because we just have so many hours in a day, so much complexity and complication we can tolerate. So, it's super important to just keep in mind that we're here to serve people in a technology environment, and to acknowledge that, even as security professionals, we have to commit to making their lives easier as well through innovation and reducing steps, standardization, those sorts of things, right? So that's usually my big message when I'm speaking to customers about my job, even though I'm not in the product business per se. We still have to do it. It's not magic, it's a lot of hard work. So, Ryan, I don't know, when you teach your courses, what's your messaging you give in this area?
Yeah, so right off the bat, at least with SEC 488, because it is a cloud security essentials. A lot of times we get students that are either brand new to cloud or maybe brand new to defending in a cloud environment. Maybe they worked with some cloud technology before, but like, how do I lock this down? And right off the bat, we cover really two things. One, again, speaking to the last presentation, IAM is so incredibly critical in cloud to wrap your head around. We try to do it with 3 different vendors all in one day, which is a big ask, but it does wake a lot of folks up. Like, wow, I can actually do all this control, which is great. But a common question that I'll get almost every class is like, well, what do you mean I have to do this? Like, isn't this the cloud provider's responsibility to defend all these things for me? And we get into some really neat scenarios. Like I'll pull up Shodan.io and like, let's look at all the wide open port 3389s that are facing internet scanners, right? And I actually just ran this yesterday, and there was over 3 million hits. So 3 million servers, I'm assuming servers, are facing the internet with remote desktop protocol, likely what listens on that port, of course, facing the internet. And if you look at the top organizations, 5 of the top 5, all cloud environments. So is that telling you that the cloud provider is the one, not doing the right thing? Certainly not. This is likely customers who are deploying things rapidly in cloud just to get the job done, maybe not understanding how to lock down the networking, for example, to defend those resources. So there is a lot that customers ultimately will have to do themselves to protect their resources, but got to give tons of credit to the vendors too. There is no shortage of documentation out there on how to more securely operate your cloud workloads. Like every time I'm reading up on a new service, there's oftentimes a dedicated security section. Like, here's how to do it in the most secure way, but it's up to you. It's up to you, the customer, ultimately, to lock these things down.
Yeah, absolutely. So we do have a job to just make that easier. I think a couple slides down, I'll talk about one specific example of a product we use in-house and that we ship that makes that story a bit easier for us. We find these things as well. So, Microsoft, I do have the benefit in my job of having access to, the world-class, world-leading threat intelligence because of our instrumentation around the world, what we've learned across working with various governments. And we do have, access, and we implement those findings all through our products, right? Basically everything we learn gets into our products, and we find them. But yes, this configuration of cloud resources, you're not, again, you have, depending on how you set up your model, any one person can enable hundreds of things, thousands of things. So the iteration rate is a lot higher and faster, right? Of what, even knowing what your inventory of things are is like super important, right? Like it's like sounds so basic, but particularly if you have a complex multi-cloud environment, that can get out of hand. Plus what you have still on-prem and doing all your interconnections there, and talking about, okay, then I'll build an identity that makes my life easier, but is it really secure, right? Like, so just getting yourself into trouble so fast. And then coming on the other side of that as a security professional, trying to reverse engineer whatever the contraption is, right? And then say, okay, let's redo this securely. Well, you're like, okay, that'll take me 2 years. So that's very typical and common. And I think, just definitely with the transition to cloud with what's available today, it's super important to get in front of that life cycle, to be a part of the engineering process in your organizations and help everyone stay out of trouble for the future, right? Like, I know we do threat model assessments and things, we do those things and we take them super seriously. But a lot of our success is when we're involved in the engineering process right up front. And we can just be a party to things coming out of the box being as secure as possible. So
Yeah.
so that being said,
I was gonna say, so it's, and not just speaking of keeping up with like new technology, we also have to, of course, keep up with what the attackers are actually doing. So STANS at RSA this year put out their top 5 most dangerous cyber attacks. Now, I will admit, not all of these specifically talk to cloud. So I'm going to morph the conversation a little bit and tie it into cloud. Like the first 2, for example, search engine optimization, boosted attacks, malvertising, and so on. The idea here, of course, is to try to get a user to click on something they wouldn't otherwise want to click on, like a Google search or a Bing search or whatever your search engine provider of choice happens to be. Like for me, for example, like if I'm going to look for Azure documentation, or maybe trying to find the Azure portal, because maybe I'm just having a bad day and I can't remember that it's portal.azure.com. And so I'll just go to Google or Bing or what have you and type Azure portal and have a result. Now, in the case of Google and many other search engine providers, they'll have sponsored links show up first. People spend a little bit of money, give it to the machine that is Google, and have their search results bubble up to the top, try to capture more of those queries, drive traffic to their sites, and so on. Well, attackers are using this too. Attackers are paying for these keywords, these ad words, whatever you want to call them, right, to try to lure you to their site. So let's say I stood up a domain, I'm sure it's already stolen by now or taken by somebody, but let's say it's portal-azure.com. And I search for Azure portal and that bubbles up to the top. Well, I could inadvertently be going to some attacker controlled website now. So again, attackers are really thinking outside the box now to try to lure you to their websites beyond the traditional, phishing attempts and things of that nature. But something that did hit cloud pretty hardly, at least woke us up a little bit, was developers as a target. The LastPass breach in particular, this was one of the first times, I'm sure it's not the first time, but one of the first times we've seen an actual user in their house become compromised, cloud credentials stolen from their local system, and then pivoted into that organization's, in this case, Amazon account, to steal all of these password hashes, usernames, email addresses, and all that good stuff. So now even the developer staff are being targeted because of things like credentials being stored on their systems for when they deploy their resources into these cloud environments and so on. And as I'd mentioned, the last 2 here are related to AI, artificial intelligence. So I kind of found this a bit comical. Both Steven Sims and Heather Mahalik were talking about these 2 at RSA. And the one that really threw me for a loop a bit was ChatGPT was their example that they gave here, where it was like, hey, ChatGPT, the question was, create me some ransomware code. I want to encrypt all the things on some Windows system. And ChatGPT is like, no, I'm not doing that. It sounds like you're trying to hack something here. So you just rephrase the question just ever so slightly. They, of course, didn't make it so evil sounding, like, hey, can you please show me in PowerShell how to encrypt a file or encrypt a folder full of files? I'm like, sure, here it is. Here's the exact PowerShell code to make all this happen. So it's just, if the attackers ask the right questions, they can take advantage and not even have to learn to code themselves in some cases to be able to pull off these crazy shenanigans. And Heather's example was trying to create a convincing phishing email. And it was amazing what these products would divulge and give you as ammunition as an attacker here. So again, just trying to tie this into cloud best possible, but just some things to be aware of moving forward in our day-to-day, whether you're in cloud or not in cloud, to be watching out for.
Yeah, like, so, on my list, right, developers as a target is a big deal because, I have like 50,000 of them or something, right? So that build all the Azure products, and we take that super seriously. So definitely, so thinking about the on-prem world, you had all this segmentation in place, and the conversation was, I can't scale, it's so hard. Well, that that difficulty also did create some natural boundaries, right? in your environments, whereas now you can just put everything in one container and it's like great, but no, you know what I mean? So so that ease of scale out and scaling, and then particularly if you have more complex environments where you have source code repositories that have their own IAM and then service principals that need to have access, and then do you make a mistake and store those keys in some Git somewhere repo? So having an understanding of that whole breach path is super important, and one thing that we take super seriously. Like when we do our controls validation, we'll talk about it a little later, we do think about it end to end, right? Like, what if we do have a compromise of a developer credential? What can they get to? What source code repos can they get to? What is in those repos that has access to production resources? What is the blast radius of that? And along that chain, like, what's the most important thing to resolve? So having that, keeping those, just really think about those credential compromise is still a huge, so we talk about sort of like passwords before, but credential compromise, and then target that with, your voice can be mimicked by the offensive use of AI. Change my password, please. Yes, I'm really this person. In some cases, it takes only a few seconds to mimic a person's entire emotional up and down of their voice. So we're getting to a place where it's like you have to have some form of validation for like any type of virtual communication, right? So don't want to like scare people, but the world is getting to where we're seeing all this amazing things, and there are just use cases that are abusive that come across, right on the other side of the coin. So it is super important to think about now, but within the cloud, you can actually see end to end, right? So that's great. You don't have these physical segmentation problems, and you do have these opportunities to have a better secure environment, but it's that ease of use has to be, that power has to be doled out proportionally.
Right. It's starting to sound like if you want to prepare for your future in cyber career, just like watch the Mission Impossible movies. So in like 5 years, that's probably what you're going to be faced with, right? Yeah. So another thing that I try to really foot stomp in the Sec 488 course, again, given the audience coming in, is trying to wrap their heads around what they're ultimately responsible for. Now, my take is it's your data, it's your customer's data, it's your proprietary information. You're on the hook no matter what as the customer. But when it comes to actually implementing the security controls, where do you have the power? Where do you not have the power to implement the controls? And where do you have to trust but verify that the vendor is handling those security controls for you? So not because I'm in the Microsoft session here, but I do ultimately like the Microsoft shared responsibility model. It really breaks down what me as a customer, I would be most concerned about. Like if I'm maintaining networking, like where do I fall into this versus where does the vendor control their networking components, like in the data center itself? Or do I need to worry about physical security of the data center? Well, of course not, unless it's my own data center, right? So I really do like this shared responsibility model breakdown. Now, what I hadn't defined is these AASs, or as a service models. And I'm sure anyone that's been around cloud for any length of time knows what we mean when we say IaaS, PaaS, and SaaS. But for those that don't, just really quickly, on-prem, of course, means you own everything. IaaS means, I like to think of it as from the operating system on up. So the Windows Server, the Linux systems, the virtual networking, allowing the access to and from those systems, either within cloud or to and from the cloud environments. And of course, everything built on top of that, the data and so on, where everything beneath that, for the most part, is going to be the responsibility, at least from a security control perspective, of the cloud provider. Like, you're not going to hire a guard and send them to a Microsoft data center and have them watch over your servers for you. It's, of course, going to be Microsoft staff doing that, or whoever they outsource that to if they do. And then as we move from PaaS and SaaS, just handing more off to the cloud vendor. Like with PaaS, for instance, most of those are going to be web services. where your developers will develop web code, push that to the cloud environment. It's just magically hosted. It's scalable, all that good stuff, available, and so on for you. And then SaaS, more or less, most of these are going to be what you see is what you get. You just subscribe to the service, you start consuming the service. You're not writing code, you're not patching systems, and so on. So I really do like this breakdown to make it a little more clear what's in front of you, what you still have to actively control as a customer in the Azure. That it'd be similar with GCP, AWS, and so on.
Yeah. Ryan, so this is the part I took a lot of notes from the talk before, right? Where there was this discussion about shared fate versus shared responsibility. You know, it's a conversation I have even in, you know, running governance, you know, where is the line? And, you know, one of the tools that we do build as part of the Microsoft Defender for Cloud stack is the Microsoft Cloud Security Benchmark. And what that does is it actually lets you know which controls for which services are applicable that you use from Microsoft Azure. And we provide evidence for that. And what also it does is it when you enable it for those services those resources that you provision, it can control the Azure policies to make those resources secure at the time that you enable it, and also at the time that you create a new one. It's also multi-cloud in the case where you have Azure resources, you can use MDC in AWS, and we recently announced Google Compute Platform as well, so you can have sort of one place to do it. So we've taken the approach because of all the customers we had, the complexities they have, you know, from both, you know, security, you know, we do think of security as its own discipline, but we know we have to meet many compliance frameworks to make sure that our products are viable for various markets and governments, healthcare, and other regulated industries, plus comply with country level specifics. And that is a very, that's also another big discussion that happens in security teams when they're doing selection of new technologies, right? How will we comply with PCI, NIST, all the DoD stuff that we have to do? So, you know, that's how we just sort of put that into action in that example for to meet, you know, we have something like 200 plus controls we use, and on all the resources in the company, we use the same thing, right? So you actually see the same control set end to end. So it is an area, right, that is we are looking to reduce the friction. And at least in my job in Microsoft, the easiest way to get progress is to just make it part of the process where my partners don't even have to think about it. It's just on, and that's it, right? So this default notion, using those options, building them in, and then as a customer of the cloud, enabling those things up front is super important. So, yeah.
Yeah, and I think this ties in really nicely to this next bit here, where we try to be a learning organization, right? So I think you can speak a lot more to this as well, Andre, on the identification of top risk and how those top risks should be handled by customers.
Yeah, absolutely. I mean, gosh, we have, like I said, we have access to so much information all the time. It's what we go through. It's what customers go through. It's what our tools see. And, you know, there's also the reality of we have an implementation that follows defense in depth strategies for each one of the services that we're responsible for. So it's like, how do we map what we learn to what's a realistic risk at the same time, right? It's a very difficult job and one that changes constantly. So one is just accept the fact that this will always be a conversation, one, and just in the culture of your organization, that, you know, we meet with the top, you know, Charlie every week, and Scott Guthrie, our EVPs in Azure, every week. What happened last week? What are we going to do to fix it this week? We meet as a leadership team at the top of the company, right? So, you know, I'm a big believer in that, and it drives the right importance for security controls throughout the organization and bakes it into the culture. So that's part of being the learning organization, but also doing the work to distill all this signal into useful actions. So you see the top risks, you know, as a security practitioner, understanding the business you're in is super important. The way the applications are implemented, the nuts and bolts of those things, so you can give a translation of action, right? So like giving just a scan report to a team and say, make all these go away, does not generally end up going well, right? So being that sort of trusted advisor for all of the teams in the company to say, if you do this one thing, you will move the security needle by some appreciable amount, is important, because this never stops coming in, right? It never stops. It's always there. It's always evolving. And you have to realize that the people that we're asking to make these mitigations, we have to make their lives as easy as possible too, because again, they have to combine these asks with their day-to-day work as well. So, you know, we take this super seriously at all levels of the organization, throughout the whole company, from the top down.
All right. So that was a quite a bit on principle number one, and it's, in my mind, the most important, right? We have to stay in front of these things. We have to evolve with the technology, stay a step ahead, or at least catch up to the attackers in some cases. But we're not doing ourselves very many favors. If you look from another interesting chart here from the Microsoft report on some of the cyber issues that may exist in these various environments, and some of them are, you know, like no MFA, right? That we've been knowing that we should be doing MFA where possible, pretty much across the board, yet it's still showing up as some significant gaps in a lot of organizations. So before we can even get to this second principle, always assume breach, we of course need to, you know, handle the small things, right? Or handle the basics, if it were, the cyber hygiene, as we've discussed before. But once we're at that state, I know principle number two, as I mentioned, is always assume breach. This ties into a lot of the zero trust principles. You'll see a few more of those sprinkled in here and there as well. And I know it's going to sound a little bit lame, but something I like to think about when I'm working with an organization, maybe it's a client that I'm consulting with, is just simply ask them, you know, just pick a random asset. Imagine that system is now breached. Where could an attacker go from there? And it would be amazing how many organizations just simply cannot answer that question, because they may not know. Like, well, what does this system have access to over the network? What credentials are on this system? What if an attacker is able to use these credentials from this system and pivot throughout the environment? Where could they go from there? So it really helps you think about, you know, your overall security strategy and your different guardrails that are put in place in front of attackers, if in fact there happens to be a breach in that component of the environment. You just kind of repeat that game throughout to try to just be more and more mature from a security perspective across the organization, whether in cloud or outside of cloud for that matter.
Yeah, absolutely. I mean, just the way we approach designing our services, right? The promise of the cloud is, you know, companies like Microsoft can build these systems at this hyperscale and, you know, be able to allocate space for you at this like lower unit cost than you could on your own, and therefore create this value. But there has to be a security promise as a part of it. So, you know, we take this defense in depth strategy very seriously, all the way down into compute and isolation, network isolation, you know, the identity isolation, you name the isolation, right? So we're doing it, but at the same time, making sure the products work and can scale effectively for our customers. So, you know, the other thing I like about this principle is that it's actually embedded in, you know, now getting to my doctor hat, right, is in really in failure analysis and engineering, right? You know, so if you think about the a lot of the big disasters around the world for industrial accidents, these are the principles. This principle is usually the one that, in its own form, in the industry it's in, that comes into play. The catastrophic failures happen when all of the holes in your defense in depth strategy sort of line up, right? So if you have only one line of defense, there's one hole, right? And that's it. So if you have four, you have to make sure that, okay, we have a principle in our engineering and architecture process is that you assume that they will fail and what's next, just as Ryan would say. So as many of those as we can pack in to make sure that we're testing within those boundaries, as well as, thinking of the, this catastrophic situation, just what will happen doing that failure analysis. And you look at, it tends to be many simple things in a row, right? Like, authentication and authorization, auth in, auth z, making sure you have the right, network segmentation policies in place, just ACLs on the internet, like that can't be your only thing, right? As you saw the example before with LastPass, the corporate machine gets compromised and joined into the network. So there you go, right? So blocking from the internet won't work if you can just sort of VPN in. So we like that approach. We implement it every day.
Yeah. And to go along with that, I mean, you could have as many defenses or prevention mechanisms in place, but, we always got to be thinking, what if they all fail? What if that defense in depth is eventually evaded? So SANS puts out through all, I'm not a forensics curriculum person or a DFIR person, but what I take away from a lot of their classes is this pickerel method. No, it's not the fish with the crazy teeth or anything like that. It stands for the different phases or strategies when it comes to performing forensics, again, whether cloud or non-cloud. And we have to, again, consider these when we're operating in our cloud environment. So we have to be well prepared, being able to be set up for success when that inevitable does happen. How can we, be as successful as possible in cleaning up the incident as efficiently and effectively as we can? Have methods to be able to identify the breach in the first place. So we can't go all in on prevention. We have to have plenty of detection, which I'll talk about here in just a little bit as well, which ties into my other course, the SEC 541 course, a little bit more. How do we contain and eradicate that attacker in our environment? Just get them out, shut the blast doors on them, get them out of the environment. How do we recover? In other words, stop it from happening again. And then finally, just like any good process, lessons learned. What ultimately led up to the breach in the first place? What was the policy breakdown, some kind of breakdown in the organization, vulnerability management, or something of that nature that allowed to get to the state that we were, that allowed the attacker to be successful. So overall, we want to be, again, shifting this into our cloud environments as well to make sure we're well prepared for when these things do ultimately happen. Right.
So Ryan, I know I'm enjoying our conversation. That means time is going by. So maybe we just skip to the third principle.
Yeah.
And then the fourth, right?
Okay.
Just in this slide, right? So, we, as much as it would be nice to within the previous, like ask an AI, please secure everything for me. Every layer, like particularly, in building the cloud, there's a whole bunch of things to worry about. We have our facilities, physical and logical security around power and cooling. So, safety is super important. When I first came back to Microsoft and took the job, the first movie I watched was first series I watched was Mr. Robot, as an example, getting in through the OT systems and doing that lateral movement, right? And I'm like, wait, hey, that's my area. So we think about that area with its own unique challenges and make sure we have a defense in depth strategy that applies to it in its unique way. Same with physical hardware and servers. We think about the hypervisor layer, we think about memory and encryption, and if we think about how we secure our racks as well. And there's a defense in depth strategy for that, right? Network, physical, virtual, same, right? What if we have some compromise? What if we have some BGP poisoning thing that happens on the internet, right? That does happen. Of course, and then of course the services themselves with the code, the containers sharing resources. Is that right for this application? Should we not do that? Should we actually enforce virtualization at hypervisors in between various parts of the way the applications are developed to protect our customers' code in case of some Even though maybe it's a low probability, the blast radius is high, so it's worth it for our customers to do the right thing there. And the services and platforms on top of those, right, which are other Microsoft Cloud services, to make sure that when we have those interconnections between, like, let's say like Office 365 that uses Azure platforms, that they assume their hostility, right, in their stack, right, and make sure that they're building the right things in between. So we give these examples in the slides around, just think about, from the defense report, we think about just IoT, OT devices have their own unique challenges and approaches, right? So
yeah, for sure.
yeah.
And just again, this is where I was mentioning before, I would tie this into the 541 course. Again, I'll keep it really brief due to the 5 minutes remaining here, but there's a lot of know-thys throughout really any SANS course, right? Before you can adequately defend something, you got to know what the heck you're defending. You got to know the landscape, you have to know the resources, their configurations, their vulnerabilities. And again, just adding cloud into the mix, we have to realize, what cloud resources we have at any given time, having good inventories, knowing where our more critical data is, knowing our security posture, where we have appropriate logging versus some lack of logging in certain areas. So along with that course, to kind of give you a taste of what is in that course, to be able to design detections for threat actors in a cloud environment, I put together a few workshops, which normally we would advertise this and you'd have to join during the 2-hour sessions, but I'll just throw them out there. I'll actually put the links in our Slack channel here under the O5 resources. And you can feel free to, whether you're in AWS or Azure, that's what I built the 2 workshops for, to see what would go through the mind of that cloud security engineer who's setting up their environment to be able to capture adversarial behavior. And it really walks through this life cycle that you're seeing here on the slide. We have to first understand what the attacker's doing, like how are they pulling off this attack? What kind of logging do we need to establish in the cloud environment to be able to catch them? Actually perform the attack. Now, I'm not recommending you do this in your corporate environment, so do not take that away from this presentation where I'm telling you to freely attack all the things. You should be doing this in a nice, safe environment, of course, like a sandbox environment. Or if you do get permission, by all means, do it in production, but get the permission first. That way you can generate the appropriate telemetry data, the log data, to be able to ultimately build that detection, be able to catch the real world adversary if they were to present themselves performing these attack techniques in your cloud environment. All right, like I said, I'll put those links in Slack here very, very shortly. All right, so last principle here, validating your security controls continuously, more or less staying on top of those security controls, because you might implement them 3 months ago, but is that the current state? Were more vulnerabilities introduced? Am I missing patches? Things like that. A lot of things to juggle in the cloud environment. And I've listed a few tools here that could be very helpful to stay on top of that. Like Microsoft has their Defender for everything, it seems, right? So Defender for Cloud, 365 Defender, and so on, to help, again, present to the end user where your deficiencies may be. And many vendors have similar solutions. Like AWS seems to have a service for every little thing related to security, Inspector and Security Hub and config service, like you name it. There's a ton of these services out there. Just use them, right? They can help you stay on top of these potential issues. So Andre, you got anything to add here for principle number 4?
No, just I think we had that one more slide there. Just the Microsoft story of, we do validate our controls. The red team is, doing that orchestration across the company as part of my team charter, to make sure we just test all of these principles all the time, right? And to validate continuously, because again, things change. You can have one of your application changes, you have a match in your detection for a string, that string changes by character, right? You don't see it anymore, right? So that's super important. And I just want to show the journey of Microsoft through the trustworthy computing memo all the way through today, where I won't talk about this in detail because of time, but we do have and recently partnered with the White House on how we're going to do AI red teaming. And one thing I will say is, to Ryan's point earlier, we do have a rules of engagement code of conduct for red teaming in Microsoft. And what that is so, folks have the right expectations of what to expect from your red team. So if you don't have that in your organizations, I'd suggest just taking a look at how we do it, or you can just copy it and make sure you have the right engagement there, because you want it to be a collaborative endeavor. And you can also make it fun through exercises. And when you tie this principle 4 with principle number 1, where it's all about learning, I think it's super important, and a really great way to drive priority, collaboration, engagement, right? You shouldn't, you should think about that as just another data source, right? As a business leader, to do these things, but it is good practice hygiene and part of governance. So that being said, that's it.
Yeah, that's all I have as well. So thanks a lot, Andre. It was it flew by, just like you said.
Yeah, it did. Yep.
Yeah, we could go on and on and on about this stuff, but yeah, thanks to everyone for listening to our little spiel here on our 4 principles, and I'll pass it back to Frank.
All right, thank you.
All right, Ryan, Andre, thank you so much. Perfect timing here as expected. And I will invite you guys to potentially take a peek in the speaker QA channel. There were a number of questions that came in for you guys. So feel free to go ahead and head over to the speaker QA channel to check those out. For everybody here, we are going to take a short break, a 15-minute break, and we will come back with the next session here at the top of the hour at 1 p.m. Eastern Time. So we'll see you all in 15 minutes. All right, welcome back from break, everybody. It is time for our next session here. So I'm going to go ahead and invite the next speakers, Mark Ryland and Ashish Rajan, to join us here. Ashish, nice to virtually see you. Mark, nice to virtually see you as well. All right, well, hey, the video is looking good here, and give you guys a moment to get set up while I do some brief introductions. Mark Ryland, everybody here. He's a director in the office of the CISO at AWS, and previously he was over at Microsoft. And so, hey, he's a living embodiment of that multi-cloud approach that we talked about before. And Ashish Rajan here, he is probably the most well-known for being the host of the Cloud Security Podcast. If you haven't listened to that already, definitely suggest giving it a download. And previous to that, he was also the head of security at a company called PageUp, and has relatively recently relocated to the UK. So Mark, Ashish, great to have you here. I'll hand it over to you.
Thanks for having us. I'll let Mark continue first.
Yeah, thanks so much, Frank, and great to see everybody here. Thanks for joining us. Again, my name is Mark Ryland. I'm an AWS old timer, been here for 12 years at Amazon Web Services. And the first half of my career at AWS, I worked in the public sector organization. And people often ask me, why did you focus so much on security at AWS? And I said, well, I sold cloud to government for 6 years, and that was the kicker that really brought me very deeply into this world that we're talking about today, and especially this topic of zero trust, which is very near and dear to my heart. So it's great to be here, and I look forward to chatting with you as the event goes on.
Awesome. As for me, as Frank has done a great intro, so I don't need to add anything to it, but I appreciate the company of Mark over here, who's way more seasoned and experienced as I am. So definitely, I look forward to having his remarks being shared as well. So I'll kick off with our presentation over here, and so I'll start with the first half of it. And I think Mark would come in after. So kicking off, I think worthwhile calling out, the first thing I want to clarify, because a lot of people have been talking about zero trust for a long time, and there's multiple definitions, multiple frameworks, and we wanted to kind of let the playing field be a bit more level for everyone to understand what that is. I want to start off by saying it's definitely not a tool or a product, as so it might be called out in the wild sometimes that, hey, if you buy this product, suddenly the zero trust problem is solved. And it's not that. You would definitely, the more important word in the conversation is trust. So having trust signals that are across your board, not just from an identity perspective, not from a device perspective, from a data perspective, from your logging perspective, incident response, I can keep going on. Basically, everything you think about from a security perspective has traditionally been a silo in terms of if there's an incident, you have to identify which part of the organization or environment has had an incident, and you kind of go down that rabbit hole for a while. And the motion of or the framework behind zero trust is the fact that it's a convergence of your networking, identity, and security in one place, where ideally you should be able to quickly identify the entire security posture of an organization in one, for lack of a better word, one viewpoint, in a way that it's an acceptable trust. Now, trust could be different forms. You could have untrusted zones within your organization, or you could have trusted implicit trust zone as well. And a lot of people would have also heard the word trust but verify. I probably say zero trust has made us question that, and now it's the other way around. You verify first and then you trust. It's probably the right thing to do in today's day and age, especially when you have so much supply chain and a lot of different kinds of access that are allowed into your traditional environment, or even a cloud environment for that matter. And I must say that there is some credit to be given for a prediction by Gartner, which is a very popular institute for doing industry analysis. They predicted that 60% of enterprises would have embraced zero trust as a starting point by 2025. And for context, that's just what, we're still 2023. So we're a couple of years away before 60% of the enterprise start adopting this. And if you kind of read into the report a bit more, I think there was like a stat, only 1% of that would be people who would have done a great job at it, or at least given a lot more effort into it. So take as much as of that you would like to. So as of less than 1% today actually have a zero trust program. So in a couple of years, you probably should see 60% of it. So I think it's a good start, but I would say zero trust is more of a cultural, more of a trust building, more of a unifying of security. That's probably the right way to explain it, and definitely not as a tool or a product. But you kind of have to understand, where does this kind of come from in terms of the way Zero Trust has been explained. I spoke about how it's an approach. There are certain foundational things you would have to cover from a security perspective to even where do you even start with that approach? And Mark would go into a bit more use cases later on, but I wanted to kind of shed some light on some of the foundations and policies of the Zero Trust world. If you have never done Zero Trust before, but you will be surprised that you probably have been doing Zero Trust in some form already, especially if you have an identity and access management system. Identity access management system is driven by the fact that identity is a new parameter. Now, as someone who started his career in identity and access management, I used to think identity is just about access management, make sure that Ashish has the right username and password, Ashish goes into the right place at the right time, has access to the right machines, and has access to the right files as he would like to. It has definitely evolved quite a bit since then. I think nowadays, the notion of MFA or multi-factor authentication is not just, hey, I need to have an SMS, but also from the fact that you should also have something like some of the modern hardware tokens like FIDO too as well. The upgrade, or the fact that I call out, you already may be doing MFA already. You may already have an identity and access management platform where you're trying to unify a lot of the identity that you may have, whether it's customer identity or whether it's your identity for your own staff, identity for your third parties that access your environment. Nowadays, identity is a lot more complex, especially if you add APIs and all these server-to-server backend and machine identity as well. So the foundation for Zero Trust would start by unifying all of that. And some of the ways you can add layers of trust, again, going back to the Zero Trust is a trust building approach. So trust but verify. So the ways you would build trust, or I guess implement trust in an environment, would be starting off by things like obviously having authentication for private areas of your environment where you want to have restricted access. To add more defensive layers, you can have multi-factor authentication. You can use things like FIDO too, as well as hardware-based security if you want to go down the path of further solidifying the usage of applications by people who are authorized to do so, and in a way that you can trust implicitly that, oh, anyone who has a username, password, and MFA with a hardware token with a higher level of trust as well. You can add a few more layers. Most organizations these days have, well, let's just say, a lot of internal and external applications that they deal with. Sometimes they have SaaS applications, sometimes they have internal thick client that they have created. So you might look at that and have to kind of think about, okay, either I can have local users in each one of these, but then we go back to the traditional silo again. The Zero Trust approach would be to have single sign-on, where you have industry standards like SAML, OpenID Connect, OAuth, as some of the foundational pieces that have been used in the industry for a long time to help you with the approach of unifying identity and access management. Now, as I said those two things, I'm pretty sure a lot of you would be like, hey, I already do that. I already have single sign-on. I already have multi-factor. As I said, we have been on this path for a long time. I think Zero Trust is just adding more layers of how do we bring this all together. A couple of other things that I would call out in the identity access management thing, which we have done in the past, but require I guess a probably slightly updated approach, is identity and IGA, or identity governance or audit process. In the identity governance pieces these days, it's not just enough for you to have your staff users identity managed. You probably also need to consider your customer users identity as well, and also have the added layer of third party that have access to your environment. I think the best example, and again, I guess no negative thoughts for anyone who had experienced a security incident or security event in their past. What I would call out is, if you have something in your third party, you're able to trust or detect it and trust it and react to it is also important these days. Whereas earlier, it was easier to just go, oh, I have a legal agreement signed with my third party. They would not have any identity traditionally. They might be created as temporary users. But these days, in the world of cloud and IoT and all of that we are living in, they tend to also have their own identity in your environment, which you need to manage. So having that as part of your identity governance process is something that you would probably need to include in your Zero Trust. So if you're not considering in your traditional user review that you have been doing for a long time for compliance reasons or for just for the security, sanitization, hygiene reasons, you should definitely consider putting this in there as well. Next slide. The other thing I want to call out is the endpoint. Now, a lot of people think about endpoint as your desktops and laptops. Some people think about it just servers that are hosting the application. In a Zero Trust context, it's across the board. So usually the easier path to start off with from an end, you probably want to unify this part as well. And you probably see this as I kind of go deeper into foundations as well, is most of these, I guess the idea behind Zero Trust is to have a unified place for all your devices, your identity network, what we spoke about earlier, because you want to be able to add a few layers of trust. So in case of an endpoint, you need to have the enough trust that, hey, Ashish has a laptop, Frank has a laptop, Mark has a laptop, but just because we have a laptop doesn't really mean we should be able to come over here. How do you add a few more layers of trust within a, like I said, laptop, a device? You would have computers, desktops. Then you can add another few layers of mobile devices. Nowadays, there are cloud desktops as well. How do you add layers of trust over there as well? A much more call out, bring your own device, usually is more of a approach to kind of go quickly. So I'm going to quickly understand the fact that how do I apply this across the board? So next one being resource ownership and tools. This is probably an easier one than to call out. Usually people are aware of this. This is more of a people thing. You're definitely able to do a lot more by understanding who the owner of the tool is as well. That's pretty much what I would say for it. So this is not more a technical thing. This is more of a people thing. Zero Trust is about bringing people together. The conversation about data classification is more around the fact that nowadays a lot of importance of trust has been given over to things like your generative AI applications. We're talking about data from a privacy perspective. Companies like Google, Facebook are being, I guess, restricted or banned from being used at all in Europe for large reasons for privacy. Data classification has become quite more important. And it's not just a matter of identifying that, hey, I have my restricted data, I have my confidential, non-confidential, and public data. It's about putting the rubber on the tire, or whatever that acronym is, basically actually finding out how much of your data is actually classified and looking at it from a perspective of everything we covered so far, identity access management, endpoint, what kind of data is actually being there. Now, once you start going on the path of doing this, you probably have to understand if there was an incident, and I'm going to talk about incident response as well as unified logging in one together, because I think in my mind, security lake, a lot of people would know about this. Establishing a security lake has usually been a, hey, I have a SIEM conversation, but thanks to things like telemetry and I guess the whole idea behind observability in security has definitely changed that quite a bit. So nowadays it's about unifying or finding a security metrics. I think OSCF is a great example, is Open Cybersecurity Schema Framework, which is available on an Apache License 2.0 for people who want to use a standard of identifying how to report security incidents. You can use that for identifying, hey, these are my security things across the board, and this is how I can bring all of it, not just from my computer, not just from my desktop, not just my cloud environment, my IoT devices, all of that are brought in together into something like a security lake, which means that when you're doing incident response, and it's a great idea to do incident response testing if you're not doing one, that helps you build a lot more robust incident response plan as you kind of go down the path. All of that helps you build the foundation, but there are also some policies. The policies that I want to talk about is basically you can't make a perfect system. As I kind of spoke about these things, I wanted to set the foundation right as well. Each one of those activity is a activity that takes a while. It's not going to happen tomorrow because Zero Trust, as I said, is not a tool. It would take time for you to find out that what's the coverage of single sign-on across the board? What's the coverage of endpoint at the moment? You might find that only production environments are, I guess, devices or applications that have your endpoint agents in. So perfect, and you don't need to start with a perfect inventory, but if you have a risk-based approach for what you would like to cover in terms of zero trust, you should definitely start there and not wait for the perfect logging, centralized unified logging, perfect centralized endpoint management, perfect identity access management system. You probably have a risk posture, at least an awareness of a risk posture already. So you may want to go down the path of at least identifying what's that initial inventory you want to start off with, and not wait for the perfect one. The last one, oh, sorry, not last one. The second one I would call out is, which I kind of started off the conversation with, you can't just buy a CMDB or a configuration management database that has been typically used for, I guess, inventory management and say, I have a good identification of zero trust because I know all the devices that are concerned or that are in my system, or at least in my environment. The traditional problem with the traditional problem with CMDB has been the fact that you're never able to identify whether the data is current, which means that your existing data may already be over, especially in a cloud world where a lot of the devices are ephemeral. You can't simply tick a box and say, I have my inventory covered. The same goes for other things like endpoint, as well as your telemetry, and like the true objective that you're trying to cover you would find that some parts of it would be covered by a tool. Like, for example, identity access management. If you're trying to do single sign-on, you definitely need some kind of if you're, as much as you would like to create your own standard, I would encourage you to find something or some product that has already done this millions of times for different customers and use that as a way to do single sign-on. Now there's a lot of cheaper options available. So use that to tick a box if you really want to tick a box for identity access management, but don't use that as a way to kind of say, I bought a product and I have zero trust. At least I have the identity covered from zero trust. So hopefully that kind of makes some sense over there. The other thing I want to call out is also some of the conversations that I've had with people around zero trust. And it has kind of migrated more from a perspective that, hey, I want to start with zero trust network first because I think microsegmentation is the thing that I want to do. I've always called out that the beginning of identity access management is already something you're doing. You can expand on that and do a really good job of it. And the problem with that is it's almost like a false sense of security to think that, oh, that's if I cover identity, I've covered everything. As I've called out, the foundational pieces also include unified endpoint. It also includes things like how do I do incident response better? Because the super goal of a zero trust architecture is that over time, it should reduce the amount of incidents that happen in an organization because you have divided your entire network with enough trust or enough implicit trust based on the controls that you've applied, that you can see that, oh, Ashish can roam around wherever he wants in this particular area because I have an implicit trust in that environment that I'm trying to work off. That is how I have usually kind of at least a good starting point, but that's not the end goal. An end goal may differ for different organizations. If you are in the government, you have SBOM and you have a lot more things to worry about not just about ticking a box, but you have to go through the verification from the government perspective as well. If you're in the private sector, but you're an enterprise, you may have to consider the part that you would have to pick your, for lack of a better word, pick your fruit. I was going to say pick your poison, but pick the fruit that you want to eat. Each one of them would take a while, so you want to savor it. You maybe even pick a grape. You might have to make it a wine. And as you kind of go through that process, you probably realize that you would never have an ideal end vision. And as you kind of keep moving, no one knew about generative AI and people wanting to do LLM systems until like November last year. But now every person on the planet wants to do an LLM system. Most organizations are also going down that path. So you might find yourself, as you kind of progress with your 1-year plan, suddenly it looks very different to where you started because now there are new priorities. So I would not wait for the perfect state. The other one I want to call out is your network parameter. The traditional network, and this is probably the last point before I kind of switch over and hand over to Mark as well. What I would call out is a traditional approach for networking, which has always been about IP address, using IP address as a way to identify. It does work in some instances, but in the traditional environment, it's not a great way to look at the context of what you're trying to solve. Traditionally, you would have gone for zone 1, but this is my DMZ, this is my zone 1, or this is my production zone. there are all these words that a lot of people would know about, but the traditional network, for some reason, the logical enforcement that organizations used to use needs to be enhanced to take advantage of the access control you would get from a zero trust environment. Now, this could mean microsegmentation, or this could mean different things based on the way you have defined your cloud network. You can use the example of, if you're, because we're talking from an AWS perspective, you can look at AWS VPC endpoints as a way to have private access to things like, which are usually internet facing. That's something which is a possibility as well. You can use things like Direct Connect and others to get, well, a more defined way of looking at how you would have better control over your network instead of just using traditional IP addresses. And with that said, I wanted to hand over to Mark. I'm going to figure out, I'm going to take a couple of minutes to figure out how do I hand this over to him. What's the button for it? Usually it's easier. I mean, if it's easier.
You're going to, I think, hand back to one of our organizers, and then they're going to, yeah, we've got a plan here. Can you hand back to
usually it's a straightforward button, but clearly there's no button.
Yeah, I think you could just go ahead and then, yeah, in the background, one of the SAMS folks is going to advance the slides.
Oh, okay, cool. All right, so Mark, over to you then.
Great, thank you so much. Thanks for a great kickoff. So this has been a really good practical introduction to the topic, I think, so far. I'm going to take this opportunity to sort of zoom back a little bit. We could have started with a sort of taxonomy of what, you know, zero trust use cases, but we thought it made more sense to dive into some of the very practical things with things like the fallacies and so forth, the foundations. But let's talk a little bit now about taxonomy and some of the use cases. And as you'll see, we've been talking, I think, primarily about kind of the first two of these, but they're all very important. So we wanted to cover zero trust use cases in more detail. So the number one, both in my list and I think in reality, and the one we've been talking about a lot so far, is the human to application use case. So this is the classic enterprise application. I want my users to be able to access those over the internet or from mobile devices, what have you. And there's a lot of benefit to that. And we want to get away from a lot of the friction involved in using VPNs, but also the security risk of VPN. The tendency with the VPN is to, again, think in terms of perimeters. I secure my access to the perimeter from outside to the inside. And then once I'm inside, everything's kind of wide open. And that's exactly what we're trying to get away from with the zero trust concepts and technology. So by actually doing per application, per device, per user kinds of authentication authorization, we're very much both, you know, improving the security, getting better logging, getting more centralization of critical access controls and assets. This is really very much one of the core use cases, and I think one that everyone kind of intuitively is very familiar with and recognizes. So we'll move on to the next one. This also is, I think, pretty obvious, and this is sort of the first two or the big two. This is the software to software, service to service use case. Think of it as microservices, not just that, hey, once my software is in my environment, it can call any other piece of software or any other service, but that all of my components in my architecture, services, microservices, they too have identities. And again, those identities can be expressed in various ways, everything from, you know, bootstrapping identities with X509 certificates, which are often present on the hosts of these systems that we're managing, using that to then perhaps transfer to OIDC tokens for kind of more modern authentication. Traditionally, this probably would have been something like Kerberos, but the point being that we want our actual software components to also have identities, and then to authorize every access that happens from one software component to another software component, or from a software component to a database, as itself a separate access decision. And what of course, the huge benefit of this is that you're going to get away from this problem of the lateral movement. So again, the old model, I have a perimeter, you know, I make sure try to keep everyone out. Once you're inside, it's easy to move sideways. And the specific problem is once perhaps a bad actor, for example, has a toehold on a particular service inside a particular service. Suppose I somehow compromise an Apache web server, and now I'm able to operate as if I was the web server. Well, if that web server has open access with local passwords to databases and can call any other service in the environment, we have a real problem on our hands. Whereas if the code that's executing there has a specific identity, and the identity is scoped and limited. Credentials are temporary. The access it can make to other services is very much scoped down. A bad actor could still cause harm, but the harm they could cause is going to be much more greatly restricted. It'll be essentially that they can do only whatever operations that software was authorized to do, which should be, again, scoped down to kind of the bare requirements of that particular service or microservice. So this whole service to service approach is really important. And in some ways, these two concepts, the first two use cases, and all these really, they chain together. It's completely appropriate that, for example, the human identity in an enterprise application gets carried into a call path, and then the software, the microservices that are then doing operations within the overall application, they're actually combining the identity of the caller, of the human caller, with the software identity, and access decisions are really made as a result of combining those two, and the kind of on behalf of usage, right? So the software is saying, if this user is authorized to do this, then I can do it. The user can't actually do it directly, but they can when coming through this piece of software. So that, again, is part of the overall modernization and creating these additional layers of defense and depth in this service to service world. Let's move on to Internet of Things and OT. So again, this is a variant really on the second point, but the focus here is not so much on the kind of microservice or building up an internal modern application, but these are the kinds of use cases in many ways drove a lot of the original IoT thinking, or I'm sorry, zero trust thinking. And that is this: I've got a device, it's out in the wild. The network is fundamentally untrustworthy because I'm using an internet or satellite connection or whatever I can get my hands on, a 4G or 3G even connection to get back from my little sensor of some kind back to some cloud-based backend that it needs to interact with. How do I do that in a secure fashion? Now, in the darker history of IoT, often, simple little devices, micro switches, what have you, would really have almost no security associated with them. It would just be a pure, network boundary type thing. So any little device that comes up in this network can do a broadcast, DHCP, get an IP address, and then just call whatever else was available. No encryption on the wire, no identity, no authentication. Fortunately, we've generally left that behind. Now, there's still lots of legacy, of course, technology that exists, but even there, we've now developed smart gateways, so you can put a smart device on a traditional or OT or IoT network that functions as a gateway, and all the traffic has to go through the gateway, and the gateway now has things like TLS encryption on the wire, modern authentication protocols, and so forth, and that becomes the way that you can then do secure access to a backend system. But again, many of these same concepts apply, but in this case, in a slightly variant way. For example, you might need to burn into the hardware, into the firmware of the device before it's shipped to the field. You might need to burn some foundational identity, again, like an X509 based identity, which allows the device now to do a PKI based authentication. So it can sign a request with its private key, and the server can know, hey, the associated public key allows me to know for sure that this particular device, which got deployed, is now is the one connecting to me. And also adding TLS to all these little devices is now possible. Again, there's, in the past that wasn't typical, and low powered small device without a lot of processing power. But the industry's done a pretty good job. I can speak for AWS. We have actually worked a lot in this space and actually added TLS capabilities and lots of other nice security capabilities to FreeRTOS, which is an operating system frequently used on small devices. So you can do things like TLS from a very low powered, $3 microcontroller. You can do things like PKI based basic kind of cryptographic operations. You can do over the air updates, which is a critical thing for keeping secure systems out there. And so this is again, a very important area where the concepts we're talking about apply very much, but in a slight variation, as we've been talking about from the first two use cases. Next one is use case number 4. This is an interesting variant. Again, not totally dissimilar from some of the other ones, but as we move into the world of doing, the modern software development world and software engineering and DevOps and so forth, very much the trend is in DevOps is to what's called no ops, which means no operator access to production systems. You really want to keep humans away from direct access to production, both for reliability reasons, but also for security reasons. You don't want to have any risk of insider access, either negligence or malicious access to data that they don't need to access in order to build and run a system. So there's a whole variant set of considerations that come into play in a case where you want to build an authentication authorization system. It's all about a secure pipeline, deploying code securely, having the right kinds of controls about who can intervene, who can update the pipeline, and separation of duties as between different teams so that you ensure the security of the end-to-end flow. But in the end, for most systems, at least for the foreseeable future, there will be these what are called break glass scenarios, or there's other terms for that. But like you may really need to log into a running system in a human interactive way, sometimes with two-person rules or two-party tools and applications, so that no one human can make an update, but under the right circumstances and with the right controls, two-person activity could occur. And in those scenarios, again, there's a bunch of tight authentication authorization controls that you're going to want to put on those kinds of systems. People use technologies like the ones we've been, obviously the ones we've already been talking about, MFA and all the modern authentication capabilities, but it may be additional layers as well, such as a secure bastion, so that, for example, all access is going through an intermediary system operated by a different team that logs and records every single keystroke, every single operation, and makes sure that you have very strong monitoring alerting on these very sensitive and delicate operations that your team may need to carry out in these operational scenarios. So that kind of operator infrastructure is again a variant. It draws on a lot of the same technology, but with a twist and with different requirements and different considerations that you need to keep in mind as you build and develop your more modern systems, shall we say. Next one is, again, an interesting variation. A lot of what we've been talking about and a lot of what really is kind of matters in the routine day-to-day is what you might say something like access to applications, access to features inside an application. Think of these as things like who has the right to call an API, who has the right to access this particular table in a database, who has read-only access, who has read-write access. These are relatively coarse-grained kinds of access controls. And believe me, if we can get those in place in a more universal way and have a more central view of who can access what, answer that fundamental question that IAM systems have been trying to answer from the dawn of time and have frankly not done a very good job of answering to this point, which is the sort of universal, like who can access what, who did access what. But even there, I think we'd be super happy if we could do that at kind of, again, the application level, the API level, the database table level. But in the end, we're not going to stop there. Okay, so the point of this use case is you don't have to go after this like right away. In fact, you're going to probably focus on the first two in this list, and they're kind of ordered in that way for the reason of priority and realistic, ability to achieve. But there's a coming point, and it may be sooner for some companies and sooner for some applications, where you're really going to want to drive that authorization capability down to the very granular level. So this is more like the cell within a database, the row, the column, or the cell, to use traditional tabular data concepts. And as we move more and more into data science, machine learning, what have you, and we have humans directly accessing data and sometimes very sensitive data, this is the kind of authorization and logging that we really want to go after. And we want to be able to have that same level of granular, that granular access control, but now to a much more deeper level into our data sources. So again, probably not going to start here. It's hard. The technology in many ways is probably not as mature as some of the other things we've been talking about. But this is where we want to get to, right? We want to be able to have not only those more coarse-grained access decisions made at the perimeter, at the proxy, at the access to an application, at the access to some features of an application, but we're going to want to develop and design our system so that we can drive those authorization decisions all the way down to these very granular data level things, as well as build related technologies like privacy enhancing encryption, where I might be able to access this data, but only I can only, for example, search for a certain type of data if that's stored in an encrypted fashion if I I can do a match on the two pieces of encrypted data, but I can't do general queries. So the privacy preserving types of data access is very much a hot topic and coming rapidly. Homomorphic encryption, which is another type of technology for allowing us to do computational and database type operations on encrypted data. These are all big and important areas that are growing rapidly. And Zero Trust has an important role to play because, again, the concepts we've been talking about apply at that data level. Last thing, again, another variation I would say on the probably version, the items 2 and 5 to some extent. But that is this, if you think about access control generally in the history of the industry, we've done a pretty good job of centralizing. So think of access control as kind of this, let's call it a left to right movement, which is on the one side identities, on the other side data or applications or functionality. We've done a pretty good job of centralizing and managing and standardizing the identity side, whether through proprietary technologies like Active Directory, open technologies, SAML, OIDC, Kerberos, kind of, which was an open technology that also has been, incorporated into some proprietary things. We're doing okay. We've done okay on that, and we've even done a decent job with what I'll call the very coarse-grained authorization, which is often based on group membership. So you have, you have an identity, they're a member of these 4 or 5 different groups, and then I can write access rules of somehow based on the group membership. It's on the other side of the equation that as an industry, we're not doing so great. We never have. And this is the fact that in every type of system, data processing system, you have generally a lot, very heterogeneous technologies used for access control. So you have ACLs and file systems, you have, SharePoint ACLs, that every system tends to have a different mechanism for taking the things expressed on the identity side and say group membership as a partial or like coarse-grained notion of authorization, because those groups can then be used for permissioning. But on the permissioning side, we have a long way to go to both standardize, centralize, and make this much more manageable so we can really answer that question of who has access to what. So one of the things, though, is software engineering practices is really begin to think about how do I externalize access decisions out of the business logic in my application and put that into some external form, whether it's a service that I use, there's services you can acquire. AWS has recently open sourced an entire authorization language and a runtime called Cedar. We strongly encourage you to use that. But in one way or another, as an industry, we've got to get away from burying access, rules deep inside application logic or in proprietary mechanisms. We've got to get that exposed and externalized so that business logic and authorization are separate. And then that authorization logic and the authorization policies have to be done in such a way that we have some hope of centralizing those. Because that's when we'll get to the more, modern and advanced state of Zero Trust, is when the same kinds of technologies that have worked pretty well for us on the identity side and being relatively standardized, relatively centralized, we need to get to that side on the access as well. And so thinking in terms of how you build applications and building your applications with, you could think of it as externalizable authorization, is really, really key. I guess we'll go on now and kind of close out our time together with a couple more thoughts. Getting started, I'll go through these pretty quickly. Item number 1, I think is the next slide. So you want to let's go back to the practical. So we've gone through some of the concepts and the use cases. Now back to practical. How do you actually make progress if you want to go and build this Zero Trust technology in your environments? She's already alluded to some of these things, but it's, start with actual practical goals, like be able to articulate to your colleagues, to those working around you, and to those who have decided to take advantage of this technological shift. This is what the things we can do, and these are the timeframes we think we can do, and start with kind of realistic, modest, practical goals, but that create a real business value, a real security value. That's how you're gonna have some success. Identify use cases. That's going to be in your next getting started item. Probably it's going to be that top 2 that I already mentioned of my 6 use cases. It's probably going to be user to application, kind of enterprise use cases, and the software to software use case, whether it's sidecars in a containerized environment, whether it's AWS has a technology called Lattice, which sort of plumbs authorization logic directly into the network layer, That's good. Those are probably going to be the top two that you focus on and begin to take advantage of, in the near term. On the next item, the idea of reference architectures. Just as in software development, we've gone from waterfall to agile. Similarly, when it comes to architecture, we have to learn. I think people are learning, but we all have to learn to be pretty flexible and pretty dynamic. Like, do your best with coming up with your kind of upfront design and architecture, but be willing and able to modify that to take into account new information, changing circumstances, changing schedules. Keep those as living documents and make sure that, again, your stakeholders are aware and that there's a process for making those necessary course corrections of various kinds, including architectural course corrections as you learn and as you develop. Realistic scope. This is another really important point. It's kind of a reflection in some way of articulate the reasonable goals, but this is the way that you'll really get a momentum in your environment. Is to have a scope that is manageable, that makes progress, it has deliverables that are tangible and that show benefit in a reasonable amount of time. These are all things that will help you be successful. The next one is a really interesting one. There's a tendency when putting in place some new technologies like Zero Trust or new capabilities, it's not unreasonable to use that as part of a more general modernization approach to, say, modernizing an application, building a brand new one, et cetera. There's nothing wrong with that. But retrofit is not a bad thing necessarily either. Keep that in mind. Be realistic that often an older application, let's say, Kerberos based authn that's running inside your network perimeter, and you decide you want to do this classic, use case number one, which is put that on the internet and make it available without a VPN. It's actually sometimes quite practical to use technology like a smart proxy in front of that, which does the MFA, the more modern authorization, and that proxy allows access to this otherwise very well protected backend. It protects it from DDoS. It protects it from all kinds of things that it wouldn't be protected from if you expose it directly. But the legacy kind of patterns then take over, and you can still do kind of traditional authorization and access logic, and that continues forward. And there's some real benefit to that, and often you can get effectively a modernized experience without a major update to the application. So either of these approaches is okay, sort of retrofitting versus larger changes, but just keep that in mind as you design. And last one is like any good IT project, or probably any type of business project, developing a group of stakeholders that really champion the ideas that you're pushing, that that have the vision, that share the vision, and that work within their different perspectives, whether it obviously IT, security team, finance, business team, people focused on productivity, all across your organization. You're going to find people, or you need to find people who will help you in sort of championing these ideas, seeing the value, seeing the benefit, agreeing on that kind of North Star, what the plan is, agreeing at those practical steps along the way. And that's how you'll really make progress and get rapid adoption. Almost out of time. I think I just might have one more slide here, or maybe two. I'll just quickly summarize. Measuring progress. Obviously, any project, it's worth making an effort to measure. Measurement is often hard, of course, any type of human activity. And sometimes it can be, reductionistic to sort of just like have numbers and say it only matters if the numbers matter. You got to combine measurement with anecdote and other kinds of ways of understanding value. But it's good to have these. It's good to have these measurements and to try to come up with those and help that be part of your championing of the work that you're doing. I think this is my very last slide now. We're on to. Is that right? Yeah. Where do we go from here? I think you've got one of the major messages is this is a journey. It's an iterative process. It's not going to be the same for your organization it is for mine or any other, but there are the common patterns that we've been talking about. I think hopefully you'll find useful. Pay attention to the foundations and the fallacies. Ashish did a great job of going through those. We'll be releasing an ebook with a lot of these very same themes. In fact, this presentation essentially tracked the outline of our ebook that we wrote. Create flexible, reasonable goals. Get the organizational buy-in you need, be flexible on the journey. Bottom line is Zero Trust can really measurably and impactfully improve the security of your organization, because we're going away from that kind of, gee, I hope this access decision to this perimeter is a good one, and I hope no bad guys got past the perimeter, which is kind of our old way of doing a lot of this stuff. We're now into this much more rich and layered and multifaceted and mechanisms that have multiple trust signals, which allow us to make much better access decisions and protect our data much more effectively and limit the scope of problems that may occur, security incidents that may occur. All these things are going to be a big win across our organizations. So thank you very much. I think we now have some time for questions.
Actually, it is excellent timing here on your presentation, ending right on the dot here at 1:15. So there are some questions in Slack, in the speaker QA, and in the discussion channel. So feel free to head on over to those. Mark and Ashish, want to go ahead and thank you for the presentation, all of that information on Zero Trust. Much appreciated. Nicely done. Thank you guys so much.
Thanks so much.
With that, we're going to go ahead and move on to our next session here. So I'm going to ask my SANS colleagues, Simon, Megan, and Brandon, to come on board and show their video here. And, unlike the other sessions where I've been doing a quick introduction of all of the speakers, hey, I know that you guys have some slides associated with that. So I'm going to go ahead, turn it over to you and let you introduce yourselves.
Hi, good afternoon, and thank you, Kim. As wonderful introduction, an awesome session we've just had there. Welcome to Myths and Missteps in Cloud Migration. My name's Simon Vernon, and I'm going to introduce myself properly in just a second. But what I want to do first is just explain what we're going to talk about in this in the next 45 minutes. It's really easy from a security architect and an engineer's perspective to identify and know exactly what organizations should be doing when they adopt cloud infrastructure, particularly from a security perspective. And it's hard for organizations because without those specialist skills, they just don't know. And what happens is they then start attributing effects and causation and attacks against things that actually it's configurations that they have implemented themselves that are therefore causing the problems. So we get a lot of misgivings or missteps and myths appearing from clients and from enterprises as they adopt cloud or as they're utilizing cloud services across their environments. So before we get into that content, I'll just talk about myself first. I am Simon Vernon. I actually work for SANS. I am the principal technical architect for the ranges environment. Now, I have a very small team, but what we do is we build infrastructures, we build CTF ranges, we build challenges, workshops, all the things that we utilize to teach hands-on cybersecurity. I'm also an instructor. I'm a certified instructor, and you'll find me teaching SEC 488 Cloud Security Essentials most often, and occasionally one or two other courses as well. I have a few other roles because SANS wants to keep my hands on the tools, not just be building ranges and existing inside these fake and simulated systems. So they actually want me to keep going in the real world. So I have a few extra roles that I play with. I have my own consultancy company, and I work with a data center, which my role there is I assist in the consultation for security for organizations who want to adopt cloud security infrastructure and utilize the the big three CSPs. Unfortunately, a lot of their infrastructure, a lot of their services just do not natively support that migration. And so we act as a springboard. We help them re-engineer their systems and get them into the public cloud. Now, I'm also a security architect for a social media app, which is rather an interesting challenge one. It's all based around sporting systems and scales from anything from 10,000 users on a day to 100,000 users, and generates terabytes of data, in particular imagery, graphics, and moving video, GIFs, etc. I've also worked with a lot of other organizations or do little bits of consultancy every now and again. So quite often around incident response and design or planning, getting organizations secure in the public cloud. I'm joined today by Megan Roddy and Brandon Evans, and I'll let them introduce themselves now.
Awesome. Well, I'm way less. Oh, sorry, I didn't know it's Megan's first. Yep, no problem. So my name is Megan Roddy, currently working as a security engineer with IBM, kind of focused on detection engineering. So if your interests expand outside cloud security, you can check out a book I just released on Amazon called Practical Threat Detection Engineering. And outside of that, I work for SANS, both as an instructor candidate for 4509, as well. I was lucky enough to help co-author that course with a focus on Google Workspace. So that's our Enterprise Cloud Forensics and Incident Response course. Takes you to the side, less of proactive securing of the environment, and more focused on when the worst does happen, if it happens, making sure your responders are ready. So I'll be offering that perspective today. And with that, I'll hand it off to Brandon.
Yes, I was just going to say that I'm much less busy than Simon is, so my introduction will be a lot shorter. Hi, my name is Brandon Evans. I'm a SANS certified instructor, course author. I do consulting as well. I'm in the space of multi-cloud and helping people set up the appropriate configurations for their multiple cloud environments. And I'm also a developer and application security person by trade first. So I love coding. I love helping people get their code to the cloud, love securing their systems that host those applications.
And it's great to have you both of you on board today and talk about this session. I'm going to drop a few questions and fire a few statements at you as well as we go through the slide deck. Okay, so the public cloud. Well, this has totally changed and revolutionized IT. It's suddenly we've got this enormous elastic environment that we can move infrastructure into. We can shrink, grow, we can move, we can utilize technology we would normally not have access to because we have this almost crowd-based innovation and collective of tools and services, which has completely changed the entire aspects of IT. I am old school IT. I started in 1999. Showing my age now as well, unfortunately. But I started in 1999. The cloud really didn't exist at that point. There was, we were still dealing with things like horrible malware in Windows XP. And every organization I worked with had huge infrastructures. They had data centers. They had multi-floored environments with huge fences around and access control systems. And this has changed completely now. 20 years later, we're into the realms of cloud adoption is huge. But unfortunately, there's this security issues that have come around this. And a lot of these security issues actually aren't the cloud providers or anything to do with the cloud providers, services and systems and solutions, but more about implementation. So this is what we're going to discuss today. So the public cloud has helped us massively, but unfortunately, anything that's incredibly complex, it basically infers fear into organizations. Now, prior to this event, I went and spoke to about 20 different organizations who I've worked with over the past 20 odd years. And I went to talk to them about cloud adoption. I went to see who was utilizing what cloud services and what their fears were and associated with implementing then trusting a public cloud platform with their most sensitive data. And what I found was quite interesting. The majority, out of the 20 organizations I spoke to, 19 are operating in the public cloud. 18 of them are operating in multiple cloud platforms. So they're not utilizing just AWS, just Azure, or just GCP. They're spread across a huge space. Out of those 20, most common issue that I had that was raised with me was a bit of a fear of compliance. They wanted to make sure that where they were putting their infrastructure was going to be safe. So when we got into this conversation with them, I said, well, how do you implement this? What's your guidance? Where do you get your information from? And I was surprised to hear that actually they got most of their information, most of their strategy, their design from MSPs, from service providers who are reselling these cloud platforms. Which is quite interesting because where then are the MSPs getting a lot of their information from? And unfortunately, I got a couple of horror stories in the process of discussing this with these organizations. How do you manage incident handling? Where does your disaster recovery planning come from? And quite often, Particularly the smaller enterprises and the small businesses, they utilize a single service provider, as in an MSP, in order to determine all of the actions that they should be taking. Yet these MSPs aren't necessarily specialists. In fact, I've talked to a couple of companies who had some really quite terrible advice. And all of this together creates this fear, this issue of, well, are we putting things in the right place? How do we deal with breaches? What's going to happen if something goes wrong? How do we maintain control of our data? It's not like you can contact one of the CSPs and ask them to turn the API off for half an hour while you fix a vulnerability or a problem or a leaked account. It just doesn't happen. So they have this fear of compliance, fear of breach. They don't know or they don't understand exactly where their data is. Now, this is an issue created a lot of times by us. We are, as security professionals, we have to communicate better, and we have to demonstrate the controls that we need to put in place in order to strengthen and harden services for enterprise. The next question or the next issue that came about and the discussions that I had with these enterprises was all about unauthorized access. Now, this has been mentioned a lot this afternoon and this morning in the sessions. And it's great that it has, because we really have to bring this to the forefront. IAM, identity and access management. It is the perimeter. It's the boundary of all of your infrastructure when you're in the public cloud. So monitoring and identifying behaviors or traits, or particularly around automated systems and service accounts, is ultimately critical. And again, this is one that came back as a fear. So we don't know who, potentially who's authenticated to our system, or how to identify what looks like malicious traffic or malicious behavior. This is awful. I mean, I imagine, Megan, particularly with your incident response experience and stuff, IAM is one of those big areas where you need that visibility.
Yeah, most incidents, I would say, start with some sort of evidence that would be IAM. You can think about phishing. We all know that users are still vulnerable to phishing, no matter how many phishing trainings we give them. And also, from the perspective of service accounts that are being leaked or publicly accessible, that's going to be IAM focused. And then lastly, we have a lot of developers who don't know secure development practices. They're putting keys in their code and then uploading that code to GitHub. And there's hundreds of open source scanners you can use to find keys in open source repositories. Those are usage. All of those come back to IAM issues, not having the right restrictions on your permissions, and all of it is going to be evidenced by IAM in the end of it.
Yeah, I mean, IAM so it protects your storage accounts. It protects the most sensitive elements of your entire infrastructure and your data. So it changes the dynamics of how you implement security controls in an infrastructure. In the data center, it's dead easy. If I don't want people to get access to the data, I put a firewall in front. I have electronic door locks on the doors. I have a fence and geese, because guard dogs are not particularly good. So we actually use, and nobody wants to climb over a fence to find geese there. So we utilize, different technologies, different capabilities to protect that asset, those assets and that data. We do it very differently within the cloud. And this is a big thing we find with organizations. One of the other issues I had with an organization, particularly, was just before COVID. They actually had service accounts that had leaked, and again, they weren't entirely sure whether or not it was done through a developer but the problem was that actually the service accounts were shared. And this was the issue. They didn't really then know which application or which platform was causing, or was the vulnerable or the source of the leak. And they had real problems identifying exactly which system had been compromised, how those keys had been leaked, what they were doing. They were playing catch up from the initial part of the incident, and it really didn't play out very well in their favor. I've had other situations with organizations as well, dealing with lost keys, with organizations who've actually created their own keys or their own break access services and then locked themselves out in turn. And this just, this goes on. it's fairly common scenario. IAM is definitely a big place where we've got to really help enterprises get on the right foot. Have you got anything else to add on to that one, Brandon, particularly about IAM? I know it's sort of also one of your key subjects in the courses and the content that you teach.
Yeah, I talk about this constantly. IAM is the most important thing in the cloud, more so than networking, because it's really hard to lock down services that contain your data behind a firewall, behind network controls. And just one thing in particular that I want users to focus their energy on is not just preventing certain actions from happening, but preventing certain resources from being accessed. So all too often people figure out what actions someone should be able to perform, but they don't specify on what resources. And as a result, maybe something that's not that problematic happens, but to all of your resources into the account, which could include so many different things. Like if you give an application read access to S3, okay, maybe that's problematic, maybe not. But if you have another application that's accessing way more sensitive data in S3, and now this application has access to both sets of S3 data, not a good thing.
Exactly. And this leads us beautifully onto security by design. And this is all about creating good strategies and good planning. But if you don't know what those issues are or the differences in how the cloud is going to function, then you don't know how to ask the right questions. And if you don't know how to ask the right questions, you don't get the right answers. This is where we have issues with organizations who provide an intermediary services to enterprises. They're trying to adapt or modify the way that they deliver their services to include cloud platform, because everybody's starting to turn to the cloud, and therefore it must be great in that sense. And then we get bad advice that's been delivered. I actually got contacted by an organization who moved their Exchange server into the cloud. They think, okay, they've moved into a SaaS as a software as a service model and moved their email system. No, they actually moved their Exchange server into a virtual machine and put it in Azure. And it got broken into because, unfortunately, it was the same. It was about 2 weeks prior to the Hafnium hacks that went across that exploited a vulnerability in OWA. And their Exchange server ended up generating or attempting to generate Bitcoins. It slowed right down. They kept turning the speeds up and the capacities up, and it cost them a fortune. And they contacted me and said, look, we really need your help. How do we deal with this? How do we fix this problem? And my first response was, well, move your email system into the software as a service platform to start with. There's no need to run an Exchange server in Azure. This is crazy. But that was the advice that they'd been given. They'd been led down that path by their skilled professionals and their MSP. So you've got to check, you've got to verify. Security by design includes the security part as in part of the platform. And whenever I consult with an organization, particularly when they are migrating to the cloud and they're very early in their journey, my recommendation is design security in at the forefront, utilize good governance when you're doing it, and move your security systems first. Now, this is a great sort of tactic for organizing your migration process. A lot of on-prem services do not work or don't have great visibility when you move infrastructure to the cloud. So move your security systems first, because you've established you can deal with this on-prem. But by moving your security systems into the cloud, gaining that leverage of those services, and particularly in multi-cloud situations where you have visibility of your security system in the public cloud, it means that when you start migrating services across, you instant and automatically gain visibility to those platforms. Otherwise, you're playing cat and mouse. You're just chasing your tail as you migrate. Security by design is critical at that early adoption process. And the reason for that is all the cloud platforms run a shared security model. And this is where Brandon comes back.
Yes, so I think it's pretty amazing that we are now 17 years into the modern public cloud. And this is kind of funny to me. If the modern public cloud was a person, it would be able to vote in the next US election. But people still somehow do not understand the shared responsibility model. And I understand why this is. Professionals in our industry like to outsource its responsibilities to a tool or a platform. You heard Ashish earlier talk about how, oh, people think that you could buy one tool and it will solve the zero trust problem. But unfortunately, it's much, much more complicated than that, because a cloud can be secure, but that doesn't mean that you're secure if you use that cloud. And the cloud can be compliant, but that doesn't mean that you are compliant in the cloud. So the shared responsibility model means that you have some responsibilities and the cloud has others. Now, each cloud has their own version of the shared responsibility model. Here's a model from Azure, and it's pretty granular. It shows the responsibility where it's clear and where it's a little bit muddy, where there's some cases where the responsibility depends on the type of infrastructure or service that you're using. And on the next slide, we have AWS's model. It tries to make the model more complete. And GCP has its own model, which is kind of like a combination of these two diagrams. And we feature that in the ebook that's going to be sent out that's related to this session, to this event today. Now, the shared responsibility model is not a way that the cloud providers just get rid of responsibility. They're not just saying, oh, this is the customer's problem, we're not going to do anything about security. It's something that fundamentally has to exist, because the clouds don't know your organization. So they don't know your security needs. They also don't know your business logic, because it is your business. How can the cloud possibly secure your business if they don't know what that business is? So the cloud user must codify the requirements specific to their organization with secure configuration. And the cloud provider is merely responsible for enforcing the configuration that the customer sets. For example, if a customer makes an S3 bucket private, but for some reason the bucket is nonetheless exposed to the world, that would mean that the configuration wasn't properly enforced. That would be a bug in the S3 platform. But if they put all of their private information in a public bucket, whose fault is that? It's clearly not the cloud providers, because they don't even know what is private in your context. So dividing this responsibility is fundamentally critical, and it's actually helpful for security, because organizations in the entire world specializes. It is very rare for an organization to design and manage every system that they use to support their goals. Did your organization create its own identity platform, their own operating system, their own servers, their own routers? Did they create their own proprietary cabling solutions? Did they create their own energy source to power your devices on-prem? Of course not. We rely on vendors to get things right so that we can do what our organization does best. And what's very frustrating to me is a lot of people don't see how that translates to the cloud. In the cloud, they're fundamentally just a vendor. They give us cloud services that give us general purpose services that we can build our stuff on top of. And everybody knows that a router can be configured securely or insecurely. Why do people forget that the cloud services can be configured securely or insecurely? Fundamentally, the cloud provider is responsible for giving you the tools that you need in order to secure your organization and your workloads, and you are responsible for actually setting up these configurations to adequately meet your business's need. Now, at the same time, this responsibility model is gray from time to time, as we saw with the Azure diagram. And Anton Shavakin, who was the speaker for the first session today, wrote a great article which is called "Where Does the Shared Responsibility Model for Security Break in the Real World?" And he mentions that the customers, quote, assume that the CSP does more than it really does. And he also mentions that the documentation makes it very clear about what the customer needs to do. And fundamentally, this is all documented. This diagram's from their documentation. There's the diagram for Azure and GCP, that's in their documentation. It is well available for people to use. So fundamentally, the user is responsible for reading that documentation. But I would go a step further, and I would challenge the cloud providers to go above and beyond their strict responsibility. They should feel somewhat obligated to educate their customers, because we have to face it, folks. No one here is going to read thousands of pages of documentation. I've read So much documentation in order to create Sec 510, public cloud security, AWS, Azure, and GCP. And I have barely scratched the surface, and neither have you. Neither have the representatives from their respective clouds read all that documentation. So it would be valuable for the security provider, the cloud providers, to give security guidance through other mediums, which to their credit, they often do. The fact that AWS, Azure, and GCP are all in this conference today shows that they are dedicated to educate their users about how to use their clouds securely. And I think that's great. And I'm really glad that they're here with us today. But one thing that I would also challenge the cloud providers to do is to have more warning messages. We all know that there are so many things that can be done wrong in the cloud. It'd be nice to show those customers, hey, you're about to do something that's potentially dangerous. Are you sure you want to do that? And then they can make an informed decision. And don't get me wrong, the cloud providers already do this sometimes, but I think that they can add more of these. They have room for improvement. We have room for improvement. Security's tough, but I think that's one way that we can make the shared responsibility model much more clear.
Yeah, the shared responsibility model is critical to organizations. I've got a particular incident I was called out to just after COVID, and about 2 years prior. There's an organization who discovered they'd been breached. How had they discovered they'd been breached? Well, they turned up at a trade conference and discovered an organization, one of their competitors, had exactly the same product as they did for half the price. That was their indicator of compromise. And it turned out that they'd stored intellectual property in a storage account in a public cloud, and it hasn't been secured properly. And they didn't realize that until we investigated it for them. They had no logging, they had no visibility, none of the ancillary or extra services had turned on. And they immediately turned to blame the cloud provider. And actually, the cloud provider had given them a lot of indications. We looked through the dashboards, we looked through the configuration settings, we looked through the recommendations, and there were statements in there saying, you need to do this, you need to turn these features on, but they hadn't taken those warnings, those alerts, and this was the issue. Now, this brings us really nicely onto visibility. And I'm going to let Megan sort of go into the more details about logging, alerting, and monitoring.
Yeah, so logging and monitoring is something I talk about a lot. So I do have a series on the SANS blog about extracting logs. And actually tomorrow I have a brand new blog post dropping about the top things to do to prepare for an incident. And one of those is logging. So we've talked about multiple times now since the start of this talk about how people can get in and how there's incidents where people don't know what happened because they don't have logs. So there's kind of 3 visibilities we can look at. There's the logging itself, all those activity logs that say the where, what, why, when, who, all the questions we need to answer. Now, the challenge here is the cloud providers will give you some by default, typically at what we call the management plane. So that's when you're creating things, deleting things, making changes, adding users, putting people in groups, that IAM level. But the problem with those defaults is a lot of times there's restrictions on the retention period. I've worked incidents where people left default logging, and ideally we'd be able to figure out what happened. They had the logs to do it, but we know threat actors have long dwell times at times. So then they go back, we say, okay, we know it was probably an email compromise. Oh, wait, the vendor only keeps emails for 30 days and they were compromised 90 days ago. And now we have 0 visibility. Additionally, I see the management plane events. Those are typically enabled by default. What we don't have is control plane events. In the example Simon just gave, where an S3 bucket was public and they didn't have the logging to identify the details, that's because by default, things like S3 buckets or Azure blobs, read access, right? Actually, any access really within those buckets is not logged. You'll know if they create a bucket, so those high level S3 actions, but you won't know when someone accessed that data unless you enable logging. Similarly, flow logging. So this next point, we talk about network metadata. When we're saying that, we mean flow logging. If you know anything about flow logging or NetFlow, it kind of gathers these network events together and provides you with things like the source and destination IPs, source and destination ports, the protocol, and the number of bytes being transferred. And that can be very valuable information. If you think about it, that's where you'd see things like C2 traffic, potentially exfiltration. But that flow logging, again, is off by default. And typically, even if you enable it, you need to make sure you enable it on all your virtual networks, all your subnets. Otherwise, you're going to have a gap in visibility. Of course, you want to be selective where you monitor because of cloud costs. But that flow logging is another example of it's available, but only if you enable of it. And if you enable it during an incident, it's too late. You've now lost the data. Unless the attacker is still active, you can't tell what they've done historically. Now, related to that flow logging, we have packet captures. I will say packet capturing is a big beast to tackle. There's a reason not a lot of people have packet captures even in on-premise environments. To get copies of every packet is intensive. But if you have very sensitive infrastructure you're trying to protect, this can provide super, super, super valuable insight. You can see that whole packet. Or if during an incident, you know the attacker is still active, you can enable that packet logging to capture it. And you'll send that to a network security monitoring device and have that available for your investigation. So one more piece of visibility, and this is where we go reactive instead of proactive, is a really very cool aspect of forensics in the cloud. Now, I also have another blog post on the SANS site and a webcast about cloud-powered DFIR. Great one to read. And one of our items is this imaging. You can snapshot things and you're able to look at that image as if it was a forensic image. So I highly, highly recommend if you do anything when you go back on Monday to the office, find out what logs are enabled. Where are they? So that's the other part, aggregation. You can go to 40 different places to find logs, depending on whether you want flow logging or S3 bucket access or IAM logs. It's all in different places. I asked my class just a couple weeks ago when I was teaching 4509, we're going over logging, and I had about 20 students in the class. I said, raise your hand if you know what logging you have enabled and where those logs are. I think there were 2 people in a 20-person class who could tell me if they had certain events enabled and where they stored those events. So it's not common that people are doing this, but the visibility gap you have if you don't enable that logging, if you don't centralize those logs, is going to bite you in the butt when an incident comes. Like, it's too late at that point. So one thing a lot of organizations do to solve this is have a SIM. Again, common in both on-prem and cloud. But SIM stands for Security Information Event Management. And what it does for you is it gives you a place not only to aggregate your logs, but to normalize. That's the other problem. If you're getting different logs, if you look at Azure logs, it's very clear that every single team has their own method of logging. Fields differ. So some people use camel case, some people have underscores between words. And so there's this aspect of normalization. Do you need to search for source.ip or source IP or src_IP? A SIM allows you to normalize that data. It typically provides metrics. You can set up alerting. You can investigate things. So like I said, for me, it's something I harp on a lot in many of my blogs and many of my talks in my class. If you don't know what logs are enabled, if I ask you right now, hey, are you logging S3 bucket access? Do you have flow logging? Are your logs being retained for at least 90 days? If you had to access your logs right now in an incident, where are they? If your answer is, I don't know, you have a huge gap and you should definitely be going back and finding out this information. So with that, I'll hand it back to Simon. I could rant about logging for a whole hour period, but I know he has a couple more things to talk about with you guys.
I could totally listen to you rant about logging as well for another couple of hours, because it's definitely one of my top subjects as well. But we talk about logging, we talk about data collection, we talk about these fears that organizations have when it comes to adopting these cloud strategies. Visibility being one of those big fears as well. Meets very well with compliance, etc. So the common questions: what are the challenges that organizations face, and what questions are they likely to ask you as a security practitioner when it comes to adopting the cloud? And it's interesting because the questions they ask actually aren't the right questions, which means they're not going to get the right information and the correct answers. How much does it cost? Do we maintain ownership of our data? Where is it stored? These kind of questions are relevant, yes, but they are not the most important. They often get sidetracked by, we've heard the cloud's really expensive. Well, it can be if you don't utilize the capability right. I've just done a workshop earlier this week where we talked about a very common tactic for cloud migration called lift and shift, which is probably the most inefficient method to move infrastructure from an on-premise environment into the public cloud. You'd literally take the virtual machine, move it into the cloud, press play, and off it goes. It's not an efficient way. In our social media app, for example, for the last 2 years, I've been trying to get the developers to assign some time to get rid of an application that runs on a web server and turn it into an app service. Now, they're a bit hesitant because they don't fully understand some of the stack. They don't have a specialist involved in those kinds of services that they can utilize or call on for that. So they're a little bit hesitant, reticent in order to do that. But if they did, it would make a huge difference. It means that we can utilize the cloud platform's native capability and scalability without having to rely on an entire virtual machine that we have to monitor, we have to patch, we have to scale, we have to update on a regular basis. All of those things change. We can streamline the pipelines to make it more efficient and more effective. One of the other questions we often get asked as well is AI involved. AI must be involved in everything. And often in security services, it is now. Machine learning can be very efficient at detecting and pattern recognition and something like that. So, yes, AI is involved, but again, organizations aren't always fully familiar with some of the capabilities of AI. And so they're not asking the question for the right reason. So what are the right questions? Well, this is the ones that I go through with an organization. Generally, when I sit down with them for the first time in the data center, they're coming to bring their infrastructure with them. Their main target is to get into the public cloud. What is it they're going to ask? First of all, they ask me all of their common questions. And then I ask them, well, hang on a minute, where are you going to put your SIM? Where is it going to be most efficient for you? Where are you going to gain most of your visibility? Again, organizations tend to want to keep their security system on premise because they think it's going to cost more because they're going to processing data or transmitting data into the public cloud. Without any review or speaking to specialists, they don't really understand this. Where are we going to process the logs? How do we maintain visibility of things between our on-prem services and our cloud-based services? This is another challenging element. If they're keeping the security system on-prem, how are they going to gain the log data from the cloud back to the on-prem, or are they going to run an entirely different screen in the cloud that allows them to collate and aggregate that data? One of the really interesting ones that I came across only a few weeks ago, actually, with a client was timestamps. They had timestamps from different systems in different regions, and yet they were collating the data. And when they were looking at indicators of compromise, they weren't able to directly attribute an action in metadata to an action in log data because the timestamps were in a different time zone. And so they were having to do this calculation in the head every time they were trying to collate a log. And it slowed their incident response process down dramatically. It meant that they weren't efficient. They were not utilizing the capability of the cloud in order to do and perform the functions that they needed to do. Another big question I always ask an organization as well is, how do you deal with the cadence of new features? How much and how fast does the cloud change? Well, I've had this experience this week. I wrote a workshop a couple of weeks ago. I delivered it in Sansfire in the US. I came home, I went on holiday. I came back, I snapshotted a couple of pages on how to create an application gateway. And 2 days later, when I delivered it, Microsoft had changed one of the pages. And so my snapshots didn't match. The cloud moves incredibly quickly. New features come out all the time. If you have a look at the preview features in Azure, for example, there are now hundreds of preview features, and some of them are amazing. In some of the systems I'm running, I think I couldn't live without some of those preview features. They're amazing. But if you don't know they're there, or you don't turn them on, you don't keep up to date with the documentation, it's really hard to know exactly what's coming in and what's going to change next. But there is a huge benefit to this. It's not a bad thing. It's great. It means every time something new comes out, it's an improvement. It's an additional something of visibility. It's an additional tool that gains you access to some data. It's additional data that you'll be able to consume or parse or analyze as part of your logging services, as part of your defensive mechanisms, and as part of your security controls. And of course, they update the documentation that goes with it at the same time, as well as bringing in new capability and demoing it, or creating webinars or feature demonstrations of this. But you do have to keep up to date. Cadence is a big thing in the cloud. Now, I actually used to work in a SOC. I was one of the principal systems engineers and architects. One of my roles in there was to make the life of the SOC analyst easier, which was essentially a battle between the sales people and sort of other engineers in the organization. The salespeople wanted all of the logs. The analysts wanted specific data. The engineers only wanted what was going to be relevant and at absolute minimum level. How do you maintain an effective SOC if you're migrating to the public cloud? That is a difficult question to answer. And it's all very much dependent on the organization. There are so many variables in play, different systems, different architectures. You're not entirely sure what you're going to come across next. I did come across an organization who were trying to move their infrastructure into the public cloud. They were running most of their services on Windows 2003, and they couldn't understand that nobody wanted to assist them in that migratory process. There was good reason why nobody wanted to assist them. They were running on very legacy kit, but they had a SOC that was plumbed in and monitoring all aspects of those services. Their primary concern, their big ask was, how do we maintain that visibility when we move into the public cloud? There's a hard challenge, the difficult thing. And then the next question that they also should ask is, how do we exit from the cloud? Now, this is an interesting one. There's been quite a lot of stories about this. There's been sort of tech articles about organizations who are now exiting the cloud. And I've got to ask yourself, why? Why would an organization go through a process of utilizing and adopting cloud services only to then back out a few years later? Is it because it's become too expensive? Is it too much money? Have they lost visibility, or are they worried about integrity of their data? Is it that actually they're concerned about the governance aspects? Where is their data actually stored? Now, my recommendation for any organization who's moved into the cloud is don't exit. Yeah, avoid an exit at all costs. Reason? Well, you're already done the hard part. You've moved a whole lot of infrastructure into the public cloud. If it's costing too much, or you haven't got full visibility, or you're concerned about governance and compliance, then you're actually doing something wrong in your organization in order to adopt those services. I've just started consulting a little bit with a customer of mine from years and years and years ago. He asked me to come in and have a chat with them. They want to adopt a new full ERP. They want to rebuild an entire platform inside their organization that manages their production services, their sales, their purchasing, their delivery and transport networks, everything else. Everything. This is a huge project. And the first question they asked me was, well, we adopted some services from company X 10 years ago. It didn't fit our organization. We want to move away from it. And my initial question was, well, okay, but how much have you tried? What have you done in order to make this work better for you, in order to to try and improve this situation. And they reeled off actually a considerable list of things that they'd gone through. It's like, okay, fine. And they gave me a list of all of these different software as a service platforms and systems that are hosted in the public cloud. And he said, if we move into the cloud, what happens if we don't like it, if we want to come back out again? And the answer is, well, it's very similar to if you're on-prem and you want to move things back into the cloud. There's a whole load of engineering, there's staging processes, there's testing, there's going to be development, there's going to be a cost associated with engineering. It all comes down to good design strategy. And where does good design strategy come from? People, processes, and technology. It comes down to analyzing, using business analysis techniques, identifying what's going to work for your organization and planning ahead and being effective by utilizing the specialists that you can get your hands on. Now, we know cloud specialists and cloud architects, a bit difficult to find at the moment. In some circumstances, definitely in the Europe is a little bit hard to recruit. But having those controls, getting the people that you need, getting the advice and the skills in-house in order to help you make those decisions, implement these changes, and actually get pushed into the cloud. They will develop and design the processes and let the CSPs, let the cloud providers provide the technology. It's all down to the implementation from you. I saw a statement earlier on in the chat, which was absolutely perfect. The CSPs are there to secure the infrastructure that they run. Your job as part of your migration strategy is to harden that infrastructure in order to deliver it. My last bit of advice is don't use hope as a tactic. It's not a good method. I think that brings us about to the end of our session, bang on half past as well. So I'm quite good on timing. We're open to a couple of questions, I think, and there is and I will hand back to Frank.
Yeah, it is actually perfect timing again here. It takes us right to the break. So, hey, I want to thank you all, Simon, Brandon, Megan. Thank you for joining us here and sharing your insights and experiences. We're going to go ahead and close it out right now, but feel free to go ahead and jump into the Slack channels to respond to some of the questions that have come in. So thank you guys again, and we're going to take a 15-minute break right now. And when we come back at 2:45 Eastern, we will resume with the very last session of the forum. See you guys in 15 minutes. Hello, everybody. Welcome back. We're just going to get ready for our last session here, a panel on straight talk in cloud security. I'm going to go ahead and invite my fellow panelists to join here, turn on their cameras and get back on. Andre, I see you. Thank you so much for joining us here. Mark, I see you here as well. Thank you for joining. And we've got a couple more people here that we are waiting on. Simon, all right. Appreciate it. Thanks for joining. And Anton, if you are there, feel free to go ahead and turn on your camera and join us here. For those of you guys that are just
mine shows
now
blocked by
joining-
host, so I can talk, but apparently not turn on the camera.
Okay,
Sorry.
all right. Well, hey, thank you for letting us know. So for those of you that are just joining us here for our panel session, we've got Dr. Anton Chuvakin here from Google Cloud. We've got Dr. Andre Alfred from Microsoft Azure. We've got Mark Ryland from AWS. And of course, we've got Simon Vernon here from the SANS Institute. So with that, let's go ahead and kick things off here. There's been a number of questions that have already come in, but like we typically do in security, let's go ahead and start with the problems, the issues, the challenges, the bad things that can actually occur. And this will be a question for all of you just to point out, well, one thing related to, well, what do you consider based on your data, your experience, your interactions with customers? What do you think is the biggest challenge, the biggest problem for cloud security? And also, correspondingly, well, what do you think is the biggest reason for cloud security incidents? And, Andre, I'm going to go ahead and start with you. If you can feel free to go ahead and chime in there. Biggest challenges, problems, and cause of incidents.
Yeah, I mean, as you, like I say, we take this question pretty seriously, and I did mention in the talk I did before, it's the sticking to the basics, the discipline around hygiene, using the right features and tools, understanding what they are, making sure they're enabled, and using the tools that we provide to make sure you're set up securely by default. We see as still, just the most common day-to-day problem, and the opportunities we see with the evolution of our products, with training and organizations like SANS is to move further, we call left into the design and architecture of applications as well in the cloud, just to help those building them just start off securely, because we provide so many solutions. The solutions you can create can be complex, and keeping track of what your breach paths are and whatnot can be cumbersome if you engage and wait too late. So it's better to know you're secure from the start, and that's where I see our biggest opportunity area being.
Great. Well, when I think I heard you say, to kind of recap here, is hey, using the services appropriately, but then also not necessarily designing it right from the start. So very good, very good. Anton, we'll go next to you.
Sure. I'm glancing at the recent data sets for cloud compromises. They're kind of the same or similar, to the best of my knowledge, across, presumably all three of us. So I think that the top spot is taken alternatively between accounts and IAM failures and misconfigurations. So on some day, I would see passwords, accounts, IAM problems in the top bucket, and the misconfigurations in the second bucket. On another day, misconfigs rush to the top, and the account stuff goes to the second spot. But ultimately, this doesn't change.
Yeah.
And so if you are, that's why this whole chorus of learn IAM and get serious about the cloudy way of doing identity. And of course, perform assessments, improve hygiene around security configurations, configuring things securely is still going to be advice. It's not very incredibly novel. And as I joked in my presentation, that password, sort of default passwords or empty passwords, is very 1980s threat, but it's there in 2020s, and we need to deal with it. So back to sort of summarized version, top issues would be either misconfigurations with security implications or account and identity mistakes and problems.
That makes a lot of sense. A lot of times it just comes down to hygiene and those security best practices in terms of configurations and IAM. Mark, what about you? Anything you'd like to add?
There similar feedback. I will drill in slightly more on a couple of the details there. One is that people don't take advantage of short-term or temporary credentials as much as they should. Like there's almost no reason now to ever use long-term credentials, especially in software scenarios, like essentially, you know, the equivalent access key or secret key. You can almost always find a better way bootstrapping temporary credentials from other kinds of easier to protect long-term credentials. That's both, you know, obviously, and for, you know, for human users, just doing the basics with MFA and other kinds of things, and for software systems, really avoiding the use of long-term credentials. And then a related point, again, it's in the same general topic, but I'll scope it down slightly, and that is doing routinely and systematically doing least privilege access for especially your software systems. We, you know, if we have tools, other vendors have tools that will tell you, hey, we'll look back 30 days in your CloudTrail and we'll tell you, hey, this is the permissions that your software's been using. You should just, here's a sample policy, put it in place. And, you know, that's very likely to work fine. You can do some maybe testing in Gamma or whatever, but chances are you just probably removed a lot of permissions that were not needed at all. And that means that even should there be some kind of credential compromise, then you're still going to be in much better shape than if you use broadly powerful principles. So it's generally still in that same identity and access management space is where I think people really need to focus attention, where I think mistakes are very commonly made. And continually, as I think all the vendors will say, is we're trying to always think of improvements we can make to make it easier for you to be successful. The shared responsibility model will always be there. There'll always be configurations that, you know, one person's, you know, open SSH port that shouldn't be open is another person's honeypot service where they want everyone in the world to try to SSH into their box. So, and the clouds need to stay very flexible in that regard because there's just so many use cases that we can't say in principle you should never do this following operation. But we also do a lot of work to make it easier to not make mistakes, to do configuration properly. The example I gave of automatically giving you scope down privileges based on past usage, things like that are, you know, are our responsibility to constantly make it easier. And we're finding a lot of success in that regard. Actually, we've seen, you know, certain patterns of common errors that we've been able to drive down by changing user experience and warning people more and doing things to make it harder to make mistakes. And I think that's another important thing that will continue on as we watch and observe and see what people are struggling with.
To make a very quick meta point on this, I think some of the mistakes can be traced a lineage to the pre-cloud thinking. It's people who configure a database server for development for some internal tasks, and they think, oh yeah, it's behind 3 firewalls like it was in the data center. But that's where mind goes. But the server is in the cloud, and it may not be behind properly configured access control. So it's kind of the on-premise thinking occasionally is the underlying reason for not making use of, say, least privilege, as Mark wisely pointed out. Like, we want everybody to always be conscious of that, but people who are not used to thinking like this for some reason, because they thought, yeah, NetSec would cover for it, are kind of leading to these mistakes. At least that's my impression.
I really like how you highlighted that.
Can I jump back in on that? That's really true. But again, I think it's important whenever you talk about cloud security to contrast it with on-prem security. And what would happen in the on-prem world is that poorly configured internal system, your perimeter, which was all you were depending on, would get compromised. That system would get compromised. Lateral movement was easy. So it's not like everything's been great in IT security until the cloud came along. Quite the contrary, I would say. But there's definitely a shift in pattern and a shift in the kinds of things you need to really be careful about it and responsible about. But I think we would all agree that when we have customers who make basic, decent investment, they tend to come back to us and say, look, I'm more confident in my cloud security posture than I am in my on-prem stuff, because I can never get the visibility. I can never get the just basic, inventory. Like, I literally don't know what half the servers in my DMC are doing. That's a very common feedback we get from customers. So cloud can really help improve security, but you also have to, it's not magic. You have to do it correctly. So.
Great. I want to go to Simon here in just a moment, and then we'll go to Andre right after that. And what was just mentioned was a kind of a change in mindset in terms of kind of thinking about a cloud-first world. And Simon, I think in your session, I think you mentioned kind of lift and shift, and I've been involved myself in a couple of lift and shift initiatives, and yeah, it didn't work out. The stuff was actually working, it was deployed in the cloud, but we were still using the old approaches. So similarly, IAM has come up a lot in all of the sessions, and even so far just on this panel here. And from what you've seen, Simon, in terms of IAM across the various cloud providers, but even in a multi-cloud environment, how do people deal with that in terms of kind of, well, you got IAM for the 3 different cloud providers, but at some point you might need to make things sync up. How do you kind of glue that together, if you will, and what should organizations be thinking about their architecture overall?
This varies massively between the organizations. I've worked with a number who, for example, still run an on-prem Active Directory, and they have synchronizations to the public cloud to facilitate some very specific services, such as single sign-on, password self-help, all of these features. I think one of the biggest problems that organizations face is occasionally it's the speed of the new capabilities that have come out through the cloud platforms. The fact that they don't often they don't often have the resources to be able to adopt a strategy around some of the newer technologies. And they still think like they did 10 years ago. They go, okay, our authentication is dealt with by here. We have fixed value service accounts for objects and web applications and databases. They're not trusting the new ways to approach some of these capabilities, and they're not utilizing the cloud platforms to the best advantage. Now, this is a problem that's created by us as security practitioners. This is a problem created by the cloud vendors, because your technology is moving so quickly. It's the things are changing at such a rapid pace that not everyone has that opportunity to catch up or has the skill set in order to be able to adopt it properly.
Great.
I can jump in on something there, if I may. Identity management is actually one of the best areas when it comes to multi-cloud, because I think all the clouds are good relying parties, and it's very straight. I won't say simple, nothing's simple in a complex IT world, but it's very straightforward to use a single identity provider, Okta, Azure AD, Ping Federate, and Google as your core identity source, especially for human users, but you can do it with software as well through various mechanisms. And then map that to roles or permissions or privileges inside of the cloud environments. And that's actually an area where we're in pretty good shape, I'd say, as an industry. We're not as in good shape as on, and I mentioned this, I think, a little bit on the Zero Trust talk, is on the authorization side. Those of you who have gray hair like me, you remember ZACML. I mean, there have been efforts made to standardize authorization in the past, and they failed miserably. And I think we're still, as an industry, we have to get much better at that. But we're trying to jumpstart that by open sourcing a critical new technology I mentioned before called Cedar. We hope everybody adopts it. It's a purpose-built and designed with a formal verification and all kinds of advanced computer science capability to be very optimized for that one, very critical thing, which is, making it an access decision. And the more we can do commonality like that across the industry, and the more we can centralize the logging from access decisions, then we'll get huge benefit. And I think that's really the future. Is we're doing okay on the identity source side. We're not doing very well in terms of kind of the cross-industry capabilities on the access management side.
Hey, I can already tell that this is going to be a very easy panel to moderate here, because people have a lot of things to say. So I appreciate you guys. Thank you very much. Now, I do want to go to Andre, though, here. Andre, we were just talking about kind of architecture, right? And Mark was just mentioning, well, some of the differences between, well, what about fine-grained authorization? And to be honest, that's the thing that I've always had challenges with in prior lives. And, the coarse-grained, the high-level, the role-based authorization, that was relatively straightforward, but the fine-grained was hard. But with that as a specific example, Andre, what do you see in terms of kind of similarities and differences in different people's different environments, security architectures, and how they approach things like IAM or other areas of the security stack as well?
Well, there's customers have so many different implementations in the life cycle. Right? The cloud boom started with, like you were saying, Frank, a bunch of lift and shift. It's like, get it into the cloud so I can start scaling and make it work. And a lot of those role-based access came along with them, even though there's tons of features in Azure AD and other platforms. There's a question mark of, customers, and just through my experience of, what do I need access to, right? There's also the role of the person who has to wake up in the middle of the night to fix things. And you will see there is a push to have this over provisioning of access just in case that sits forever, that needs to be managed. So, this, there's a, one is, there's, if you're looking into building a new cloud application and knowing the services you're going to use, what ports you need to open, what that least amount of footprint you need, I think, you can put the thought behind that and make that as part of the architecture process. But again, you have to make just, in a lot of cases for like legacy applications to de-risk them, it has to be a real project. You have to ask these questions. You need to know the scenarios that exist. And, hearing what Mark was saying earlier about, hey, let's put some stuff in logging to just show you, here's what we think your footprint is, here's what we think your baseline is for this particular account, and here's a policy that come on the outside of that. I mean, that is a big ask. As a networking guy, it's similar. We ask in the past, what ports do you need access to? And a lot of the times the answer is like, I have no idea. And you have to have a similar approach where you go through logging, you try to build a baseline, you say, this is what I think, I'll enforce it, and then we see what happens, type of thing. So, I think it's a similar journey that we have to go through to evolve the workload content, right? To be more cloud native, to take advantage of PaaS applications, and to make it less complex and use some of the native tools in the cloud. But we still have a whole bunch of work to do between now and then.
Yeah, you mentioned over permissioning, and that is one of the best practices, as we're saying, is to try to limit the amount of access that different entities have, whether it be people or machines and identities and so on. We do have a question from the audience, though, and I want to encourage everybody in the audience, feel free to go ahead and add in your questions here in Slack so we can go ahead and ask our esteemed panelists here. But specifically, it's a little bit more of a specific question here related to a break glass account. Do any of you have any suggestions on best practices for temporarily granting high privileges, maybe to a developer to resolve a critical issue, and doing user service account impersonation, or anything else that you might suggest in those types of situations?
I just know we have guidance on this. I'll share it in the resources page. So it's like I don't have a short pithy, hey, do X and you're okay. But there's definitely art to using break glass accounts, because ultimately the worst thing you can do is turn break glass into normal access, which is like ultimately the most self-defeating thing you can do. I've seen it done, and then like you really are not doing break glass right.
I mean, there's also, we have features, all of our peers in the industry do as well. About just think about time bound, so just-in-time access as an example, using like Azure JIT to say, okay, if you think about, hey, I need something very permissioned heavy to just get something done, like having that still go through some kind of SLA-driven approval process that's monitored for access and has a very specific purpose, a very specific reason and rationale that gets approved through an escalation, as sort of the last resort. There are tools and concepts around just-in-time access that facilitate and help for those. But for everyone to have a break glass account in their back pocket like that, no, right? There still must be some level of approval and checks and balances in place.
I was asked this actual question in a conference by a previous boss from another company who came and approached me and said, I've been looking forward to meeting you again. So I have a question for you. What do you utilize as a break glass account in a SaaS environment? And my default response was, are you utilizing root accounts for anything? Because these are the ones that really you should be saving back as your break glass accounts. If you lose access to that root account, then you've got major problems. You don't own the tenancy or the subscription anymore. And I think it was the reason he was asking was he was actually dealing with a incident inside the organization at the time around that particular circumstance. And it is not uncommon for organizations to be utilizing high power or high privileged accounts on a day-to-day basis. We still have the same problems we had 15 years ago with domain admins logging on as domain admin constantly. So yeah, just a different approach and a managed methodology of dealing with user accounts. Very similar to how we were on-prem.
Yeah, I'll chime in with, there's a couple of different dimensions. One is sort of the rate class or the highly privileged user of the cloud platform APIs. And of course, there's also, and will still be for a long time, the question of sort of privileged access to hosts or to particular container environments or whatever, the kind of compute nodes or databases, what have you. So there's kind of multiple levels of this question. But I think that certainly the industry trend is towards quorum-based access, where you have essentially multiple privileged users who have to agree in order for some action to occur. And I think we've got some, we'll post in the follow-up resources some blog posts and feature capabilities we have. I think the other providers have similar capabilities. And I think you'll see us doing more work in that space as well, because it is perhaps one of the best long-term solutions is to have a cooperating set of principles. And you can have quorums that includes, software and humans too, right? That's a pretty interesting use case. There might be a very specific operation that you can't use the access management system to, allow or deny something because the privilege, the fine grainedness, if you will, of the identity management system doesn't allow you to get down to the level of like the value of a parameter. Like you can permission this, site arrangement, not that site arrange or something like that. But you may have a real use case for locking down those kinds of privileges. And what you can do is use a quorum-based system where you have one or two humans or one or more humans, and you have a piece of software that it's the combination of those multiple parties that can approve that. And the only way to get that work done is if the software in the end that you especially created and permission and sitting there as a Lambda or some function as a service is what can make that, flip that flag. And that's another really interesting use case that we've seen for quorum-based systems. It's not just human, it's also human software Quora.
Great. Hey, you know what? Let's switch gears a little bit. DT here online, he has a question and he says, hey, I'd like to see some examples of good architecture. What resources are available? But specifically, he mentions like incorporating the SIEM into the cloud. So for, logging and monitoring, we know is a challenge for many security teams. I've seen many enterprises with a traditional on-premise SIEM, but also, of course, using various services in the cloud. But this means then the problem is if it's not all centralized, as has come up before, well, the analyst has to go to multiple locations to see the data, the alerts. Where do you see this going and what do you recommend from an architecture perspective? We'll go ahead and start with Anton and then go to Andre.
So this is actually kind of funny because right before this, I was finishing my SANS webinar deck on decentralized log analysis for next week. So I almost feel like saying, I'm not going to answer, come to the webinar. But in reality, I'll go to the point that there would be types of telemetry, types of data that you absolutely still have to centralize in one place. And one place may be a distributed system. It may be a software as a service SIEM, like, well, some of us here have, basically a modern system that can efficiently store logs, perform detection, and deliver the security outcomes. However, there would be log types, there would be telemetry traces, there would be other types of traces that I may be willing to leave where they are and kind of hope for the best. Would they be there when I need them? Maybe. So for the logs where this is not good enough, you're centralizing. And in this case, ultimately, when I say you centralize in a SIEM, that means somebody somewhere will pay for hard drives. There's no way around it. We'll pay for hard drives, you'll pay for hard drives, Mark would pay for hard drives, somebody would pay for hard drives. There's no way for you to have logs available for PCI assessors and then have nobody pay for hard drives. They are stored somewhere. So in that sense, if you have the pressure to have the logs in one place or a few places, you are deploying a SIEM, some form of distributed SIEM, some form of software as a service SIEM, but you're not really leaving logs where they are. But the cases where this stringent approach is not truly necessary are manifesting, right? We do see cases when people deploy a lot of software as a service applications, and they have their own little log storage. So you may need a system that can gather data, perform the analysis, and then give you the outcomes. Ultimately, we live in some kind of a mixed world of centralized into a few places and then leaving some data sources to be queried in a distributed manner. And that will be my answer, next week. I don't think it's magical, but that's what I have.
Great. Andre, anything to add there? And specifically, we've talked about a traditional SIEM, and we kind of see the increase in adoption of data lakes as well. For example, you've got a Snowflake or a Datadog, and various cloud providers, of course, have different data lake related services. Where do you see this going?
Yeah, for us, we have our Sentinel product and log analytics and for operations, and at least look, I can switch hats to my day job. You think about what's the best experience for a threat hunter. They need to see whatever possible to stitch together a timeline of events. So, leveraging cloud native sort of gets you a lot of that out of the box. Specifically around secure architectures, we do post libraries, and I can share them in the Slack channel around what we give as far as secure architectural guidance to build applications in Azure that'll meet various like IL5, DoD guidelines, that sort of thing as well. So, on both sides, it's, building a good defense in depth tiered architecture with the right principles around identity access management, as well as what's your observability story, and being able to leverage the cloud in a way that gives your ability to build the right context in your detections to make sure that they're actionable is super important. And that will take some normalization and things, as was discussed in the previous talk, right? So, knowing what it takes to build a great detection can help guide a little on what you should be enabling, normalizing as far as events, and saving and storing, right? To make sure you're doing that in a cost-effective way as well.
I agree, and particularly with some of the statements that Anton made there as well. And approaching logging from a holistic perspective, where you have multiple environments, multiple systems on-prem, in cloud, multiple cloud platforms, having the idealistic view that you're going to be able to get all of your logs in one place and in a single chronology is idealist at best. It just doesn't happen. And so it's often a case of best effort, identifying what's critical, identifying what's going to provide you with those indicators of compromise that are critical to know, but actually maybe storing things like images and other associated or additional log data, for example, in localized locations, because when you know something's happened, you can go off and find it, but it's not always efficient, effective. There's a cost involved, there's transport involved in getting everything to one place. From my perspective and from my experience, it's just, it never happens, even with the best intentions.
I'll take a slightly contrarian view, not in a very fundamental way, but and it's all around the experience we've had in the last year with something called OCSF, so Open Cybersecurity Schema Framework. I encourage people to go to ocsf.io, take a look. We launched it a year ago with a bunch of partners and customers. We celebrated the first anniversary of Black Hat last week. We had an event with a bunch of customers. I've never seen so much enthusiasm in my life for low-level technology, which is just standardizing security telemetry. I mean, I had the Comcast representative was beside himself with joy for this, what seems like a silly technology we should have invented a long time ago. And what it made me realize is that data munging is just a huge problem still for security people. They just spend way too much time getting data to talk, one system to talk to another. And it's ridiculous. And I didn't realize how ridiculous it was until we started working on a solution and seeing the happiness that it brings when people, when they think actually there's now 140 participants and 75 vendors, they're all signing up to emit or consume their security telemetry in a standardized format. The other point I want to make, and it's related to that, is, and I think Anton's right, you're paying for the storage of that security data, where somebody's storing it and you're paying for it one way or another. But the problem that we always heard from customers was, I'm using 3 or 4 security tools. They all make a copy of my security data. Now I'm paying for 4 or 5 copies of my security data. So why is that? Why can't we bring the tools to the data? And so I strongly believe, and it'll never be perfect, it'll never be fully centralized. I strongly believe that security data lakes are the future, where you have a stored, cheaply stored in Parquet format in a blob storage. You have a ton of your data, it's normalized with OCSF, and then the tool vendors bring the tools to the data, you permission them, you give them access, you have audits, and you know exactly what the tools are doing. And it also enables a whole new kind of startup approach to security analytics, because if I'm a startup with a great machine learning idea and I need, 6 months of your data to show you how awesome my tool is, how the heck am I going to get access to that? I can't really give you like a free tier 30-day trial, because you'll have to copy all your data into my thing or whatever. It's just super hard. But imagine that if I had actually a reasonably complete security data lake in my environment, my customer under my control, now I bring your little machine learning dealie into my environment, run it for 30 days on my last year of data, and it brings amazing results. It's like, wow, so today it's like everybody's complaining, rightly so, that they have to deal with 5 different tools, none of which really talk to each other. But I see a future in which we have a very much more common data set in the data lake, and we're maybe using 20 different tools, and it's okay to use 20 tools because they're like widgets in a dashboard rather than completely separate products with separate UIs that don't talk to one another. So I'm pretty hopeful that we're moving towards more standardization, more centralization, although again, it's never going to be perfect, but I think that's a trend that I see.
Great point. That's related to something that Pablo just asked here in Slack. And he was asking for your perspective on, when cloud customers should go with a cloud service provider native security tool. As we know, there's many security tools that each of the cloud service providers offers versus a third-party solution. And a lot of times those third-party solutions, like for a CSPM, a cloud security posture management solution, one of their arguments is that, hey, look, we can give you visibility across all of the cloud providers. If you're multi-cloud, then, hey, you might be able to leverage us versus just using a native cloud security provider solution itself, because you've got now management across that multi-cloud environment. What are you guys' thoughts on that?
He does realize he's asking cloud providers, though, right?
Oh, say that again?
He does realize he's asking cloud providers.
Anton volunteered to answer the question.
I mean, it was my job at Gartner. That question was actually really common from clients, and I still go through, the papers I've written, papers that I've written by my former team at Gartner, and I actually see a very interesting pattern in that. And the pattern is that Gartner thinking that's absorbed from many end users strongly favors tools built by cloud providers. It's not any kind of secret conspiracy. There's nothing of that sort. It's very clear that if you are using one cloud, it's very likely the answer is use the tools from the cloud provider. Now, things were simple when I was at Gartner. I left in 2019. And today, I do see a lot of people actually favor multi-cloud tools, which is an interesting thing. And I'm going to set this up and drop the hot potato on my other panel members, by the way. I'm preparing for this. So almost nobody is single cloud nowadays. And as I think one of the SANS speakers mentioned, either you're multi-cloud or you're involuntary multi-cloud because you acquired somebody. So I think the world of multi-cloud makes it much more difficult. And that's where I hand it off to others.
I mean, just Microsoft's security approach is that, we've gone in on investing in multi-cloud just so, again, in my day job, right? We do have acquisitions, as Anton said, that they come in all the time and they're where they are. And we still need to have a good security view, presence, control, without just, 2 years of a redeployment or split screens and that sort of thing. So just, from where I sit, right, I get the benefit of that approach, with our Defender line being multi-cloud and having support in multiple clouds. So we recognize the trend for sure, and we think it's important and here to stay.
A few things I've come across with, particularly with organizations who have adopted multi-cloud strategies. They will look and review external or third-party tools in order to identify. And what we tend to find is they will give you
I don't know, 85% coverage of visibility of the cloud, of all of the cloud platforms, or maybe, slight variances between the CSPs themselves. Whereas you use the native tools, you get generally almost full visibility of what's going on inside that environment. So if you're 75% in AWS, 25% in Azure, you're probably more likely to want to use AWS native tools in order to be able to identify the bulk of the things that are happening there. And you want to kind of stretch or pull information from the other CSP or from the provider in order to just fill in those gaps and cover those blanks. If you are evenly split, then it's probably the situation where you're going to utilize some more of a third-party service. At least that's some of the approaches we've used in the past, and they've worked fairly effectively.
So I've been with AWS for 12 years, and I remember the days when, like, where were you other guys? Like, for 6 or 7 years, it was fun. This was not an issue. But now it is, of course, and it's good. There's, competition drives better products, better capabilities. So it's a fun time in the industry in a new way. And these issues definitely do come up, and we hear from customers that they need support in that regard. So, we try to do a little bit of both. We try to build capabilities that support multi-cloud and even hybrid architectures, right? Like our systems manager tool, which can manage your virtual machines on premises and on other clouds. And, we continue to build those kinds of capabilities. But we have a huge and thriving partner ecosystem, and we absolutely love it if, customers find, hey, there's this partner that does this thing really well. And we're like, great, we actually, a lot of those partners run their businesses on AWS, so they're great customers as well as partners, and they provide some of the capabilities that people are looking for. So I think we'll continue to do both. We'll continue to obviously focus a lot on native tools, because if we're not doing a good job securing our own cloud, then it's sort of silly to put a lot of resources into multi-cloud. But as we've, I think, built that pretty firm foundation, we're doing more that is able to kind of see more broad visibility in our native tools. And then we'll have partners that, cover whatever gaps that we're not covering or that other folks are not dealing with. And so it's, it's not a simple or clean or, story of the, here's the answer. But I think as an industry, I think we're doing a pretty good job, and customers seem pretty happy that they can get the results they need.
Hey, Mark, I love the subtle jab there. It's not a panel unless there's some small amount of conflict or controversy. So feel free to keep it coming. Yeah, nicely done there. And, hey, Dustin here in Slack points out that, hey, the decision for tools doesn't have to be binary, right? It doesn't have to be just third party or versus cloud native. Partly it's, hey, what's going to work the best? What is perhaps best of breed in terms of fitting into your overall ecosystem? Now we got.
Well, that's exactly why we're trying to develop tools like OCSF. You can pipe data from platform to platform, tool to tool, then you're going to get good results, even if you have lots of different there's some complexity or federated search. Anton alluded to that. That could be very reasonable to have kind of a federated search capability, but you do need some degree of schema standardization, because the one thing that kills us is when your way of expressing an IP address is not my way. And we heard an earlier talk where people saying they're not even time standardized, for goodness sake, right? If you don't have at least UTC standardization, you're in terrible shape, because you literally have no idea what happened when you don't have timestamps that are somewhat well correlated in your security realm.
Yeah, now jumping around here a little bit, earlier DT asked, related to architecture, what resources are available for cloud migration. And so, of course, we know that there's all of the cloud providers have the cloud adoption frameworks. There's the security reference architecture, for example. And this is related to what Kirk just asked, is, even despite all of the good security controls and cloud security best practices that we've been talking about, some organizations still do have hesitance to move to the cloud. And, what advice would you give? And related to that, partly the fear is sometimes, excuse me, is that there are, just like any piece of software, at some point in time is going to have some vulnerabilities. And when these vulnerabilities are found in the cloud provider itself, well, then what should we as customers be thinking about? And what is the process that you guys use to inform the customers of those sometimes more critical or sometimes less critical issues?
I can probably try to drag my dusty ex-Gartner hat and try to start this one, because it's another data set that I've tracked pretty obsessively. Do people still perceive cloud being a security risk compared to their current environment? And I think that The wave of this have waned quite dramatically before maybe 2018, 19. So it's almost like I suspect that number of people who say, I'm afraid of cloud, it's too insecure. It's probably a really small group. At least I don't question that they exist, but at this point, my data points out that this is an increasingly small group of people. And there are robust arguments to be made by all three of us that our data centers, our infrastructure, our security controls, our pretty much everything is done better from the security point of view that most, if not all, data centers on the planet. Like, to me, that question is answered. What becomes the new question is, do you really use cloud built very securely in a secure manner? It's all this back to IAM and configurations becomes a question. So it's almost like if somebody says, I'm afraid of cloud, what if something breaks? What if it's not secure? I would say, no, actually, it's not going to break and it is really secure. But when you start thinking of your use cases of cloud, your interaction, your applications, your code, your other stuff, that's where you need to focus your attention. You can still screw it up in a data center, but you need to learn how things are done in the cloud and do it the cloud native way. Like I stopped fighting this, convince me that cloud is secure. Of course, my boss, the CISO, has written this 8 megatrends why cloud is more secure, which I really love as an argument of like, sorry, this question is answered. Cloud is more secure. Please calm down. Focus your attention over here.
Just pausing here to give others a chance to chime in.
I mean, Frank, what I would say is I'll just be quick. You know, there's a human element of that where it's more like, hey, I put all of my risk for my whole business into one place or a few places, and then there's a request for transparency in the process of securing resources, right? So like just in Microsoft Store, we have the MSRC, the Microsoft Security Response Center, our threat intelligence teams. We put out all these reports and what we find, and some of that I shared today. We do, you know, we have some idea of what nation states are doing to have nation state advisories. So I'd say the security apparatus at Microsoft is like way bigger than like, you know, even I can like when I look at it, it's enormous, right? And that's sort of part of the story. So, you know, and knowing that, you know, me and my peers in the industry are working overtime for our customers, focusing on security all the time. I would say that is something to think about, where you have these operation centers working 24/7, 365, threat intelligence analysts, you name it, up and down the stack of security, making sure that our products are secure, our customers, if, you know, if we're detecting things with our customers, we're letting them know proactively, sending advisories, having bug bounty programs that we're paying money for to find vulnerabilities that we may miss, that sort of thing. You know, it's a big deal. And, you know, in the researcher community that we adore and love in Microsoft, that we have a good relationship with, you know, we handle that all on behalf of the customers. So, you know, we do what we can to be super transparent about all of that care we take in the process, and that's typically what customers talk to me about, right? It's like, just let me see what's happening, and we definitely go through that with them.
I think it's very much a perception thing, because, you know, you as cloud providers, you are hosting the infrastructure for hundreds of thousands of organizations across the world, and when you do suffer an incident or an outage of some sorts, then it's very public. You know, people really see and notice this, whereas, you know, an organization who is running a fair unknown web application of some sorts inside their internal system, and they've, you know, it's got a hole out onto the internet. It's determined as being vulnerable. There's a million installations of it across the world, and they all get compromised. They all have to fight their own fire. Whereas the cloud providers, you're in a very unique position where you are effectively crowdsourcing a lot of information from a lot of different sources and people, and very experienced
capability where you can actually fight that fire together collectively in order to solve those big problems. So from a perspective, it's bad because, yeah, there's a big vulnerability hit. Everybody gets notified about it. It ends up in a lot of the publicized presses. It becomes public very quickly, whereas individual ones, they do have to look after it themselves. So it's a trick. It is a difficult one because, I do firmly believe organizations who have strong and good implementations in the cloud are actually more secure in the long term than they are by running their own dedicated infrastructures.
Yeah, I totally agree. And we've seen some of that data that, organizations that are on a modern stack in a modern environment, like with the cloud, automation, infrastructure as code, and so on, they are able to more quickly close that window of exposure, respond more quickly, respond more effectively, and just modernize their stack a lot faster. So definitely that is the case. I think largely, right, industry-wide, it is an answered question. Now, let's go ahead and switch topics here. AR asks about ICS and OT, industrial control systems, and that environment as compared to your traditional IT environment. Now, I do know of some utilities, energy companies, and so on that are starting the move of various systems and services to the cloud. And based on what you've seen from customers, what you've seen in the industry, what would you say are the challenges associated with organizations in this environment moving to the cloud? And what do they have to think differently about versus what we as in a regular enterprise might think about it with IT?
I can kick this one off. There's a fellow by the name of Art who I talked to this stuff about as he's on the call today. So just great to see so many people that I knew from the past show up here today. One is, just think about the concept of a data center. There's tons of control systems in place that are highly outsourced for their maintenance care, where you have vendors walking in the door with their own machines, plugging into some type of local area network to do maintenance, and you have no idea of what's going on in a typical implementation. A lot of those systems are also behind a very large capital investment cycle. So when I build a new thing, a new data center, that starts with procuring land 10 years ago, building concrete, building systems, and doing this maintenance is you have this stack of this vendor supply chain that sort of comes in the door and needs access. The protocols are not standard at all in those layers. They are just collections of protocols over years and years that have no concept of control, or they're all broadcast everywhere. And that's a big part of our efforts in securing our data centers, to make sure we do have some controls there. Your defense in depth strategies are super important. So you have to think about that layer of the environment, to where maybe there's this 15 years ago in corporate IT was, where everything's on a broadcast domain. There's no network segmentation. You have no idea who's talking to what. Maybe the only account on one of these machines is the super user account, right? So it's an area that needs a lot of focus and attention, and a dedicated focus and attention, because of where it is in its maturity, just due to the fact that these are a bunch of embedded systems that don't have many smarts to them, and you can't put much mitigations in place in each layer. The big problem there, at least the top one for us, is still what is deployed in those areas? What is the inventory? You have to use passive scanning technologies, like Microsoft has Defender for IoT, which we implemented those span ports for you to be able to just at least see what's talking in those layers, so you don't have to talk to 10 different vendors to maybe understand what you have in that part of the environment. And we have seen, lateral compromise come from those places. Introduction of malware, so not having the right segmentation in place, jumping into your production networks is a big risk area. So it's one we take super seriously here in the company to defend against.
I'm not an OT guy. I'll just skip this one. I don't have the depth to answer it.
I'll jump in with a few thoughts. In fact, I just did a webinar with a partner, Dragos, couple weeks ago that I think had some good content for people that want to go deeper on this topic. But I think that, there's just a lot of elements to this, but part of it is often a lot of, yes, dated equipment using old technologies, old protocols. And we touched on this in our Zero Trust webinar because some of these very same issues arise, how do we modernize and create authentication and trust signals beyond just, hey, I'm on the network, I can broadcast and find things. And I think that there's a variety of things that go on. One of which is that you begin to break down the segments of your network and you put upgraded gateways or proxies in place. So yes, there's a broadcast domain and every machine in this part of the factory can talk to every other machine, but there's also, as was mentioned, the listener. It's recording some of that information. It's doing this with device discovery. It's an upgraded and modern device, and it's the gateway to the outside world. So when those devices, have to proxy out and get a firmware update or whatever they're doing, you have a lot more visibility because you're essentially running, these sort of smart proxies in the middle of what were previously sort of flat and relatively insecure networks. So I think that's one pattern that works well. And there's another pattern that people will just add a whole new layer of sensors. Like, we have capabilities. AWS has, sensors, vibration and sound sensors, literally just inexpensive devices you can slap on a machine. And based on machine learning models, you can figure out patterns like this machine needs servicing because it's noisier than all the rest of my machines. And there's really interesting what you can do with sort of like upgrade in place of relatively inexpensive new technology to supplement some of your older operational technology. So I think those are kind of the couple of patterns I think that are worth mentioning. One is, and cloud-based backends for these various systems. The third pattern I'll mention though is there are these scenarios where super low latency is, controller type systems is actually very relevant. And in that case, as fancy as a cloud technology stack might be, if it's 14 milliseconds away, it literally cannot serve the function that's needed for that particular environment or those controllers or that switching system or what have you. And in that case, cloud vendors have built sort of forward deployed technologies, whether it's, for us, it's like snowballs or outposts. In fact, we have this technology, which is like a, deploy onto customer prem rack or 5 or whatever of EC2 Nitro gear. That technology was actually developed not as a, it's sort of misunderstood as like, oh, it's more secure, it's on-prem. No, that's not the point of that technology. The point was we had customers that said, look, I need, 50 microsecond latency between the software that I want to run and my, in this case, telco switches was one of the core use cases, or my 5G network where I have, edge switching I need to do. And I want to run EC2 type workloads, but I need to sort of forward deploy those. And so it was all about network latency. And so that, again, there are solutions for some of those approaches where you literally like push the cloud out to the edge. And that is, of course, a big trend as well. So those are a few thoughts I thought might be helpful.
Great, thank you. Now, switching topics here, we've got a question that is not necessarily cloud specific. And it's about how do you prepare for quantum cryptography? Now, the question is, I think, a little bit of concern in terms of data being able to be decrypted. Now, I think we know with quantum, and when there are powerful enough quantum computers, it would really be that the asymmetric encryption that is going to be more impacted versus symmetric encryption in terms of the way that the algorithms work and what quantum is going to provide. But any suggestions, any thoughts on from each of you in terms of how you're thinking about quantum computing, what people should do to get prepared? The person in the audience said that they think maybe some of the cloud providers are already implementing and making some changes to get ready for this future.
Sorry, I'll go first because my answer would be really short. So I'll post some links. Again, not my area. I know we do a lot of work here, and it's a lot. My PhD is not quite enough to understand much of it, so that's why I'll defer to links. Sorry.
I can jump in. It's actually an area I know a fair amount about. It's funny. The very same vendors you're looking at are both developing the computers that will break, hopefully. Be powerful enough to break asymmetric cryptography. And also we're going to have to defend against the post-quantum risk, which comes from the fact that, if this theoretical future sufficiently powerful enough qubits that, in the right kind of error correction and we'll be able to make our existing asymmetric protocols very vulnerable. So I think probably all vendors, I know for sure AWS is working very actively on post-quantum cryptography. We were a member of two of the submission teams for the NIST PQC process that started a number of years ago. We've now implemented and open source the two current, leading candidates in kind of the early stage of standardization. You can go to GitHub and you can download our implementations of quantum resistant cryptography and incorporate that into your systems if you like, and we'll continue to do all this very significant investment in this modern cryptography. We'll continue to do in the open so that everyone in the industry can benefit from it. And we actually have a couple of, we have some production endpoints. So for our key management service, KMS, for our secrets manager, and for the ACM service, all three of those have post-quantum hybrid key exchange options in production today. So if you have the right client, you can upload your secrets to our secret related technologies using the hybrid exchange, which means the keys are encrypted with both elliptical curve and post-quantum crypto, both. And that way, if problems emerge later with some of the post-quantum algorithms, and it takes a long time to work out all the flaws in new cryptographic algorithms. So there's no doubt that there will be changes and improvements, but you get basically at least as good as today, plus hopefully much better encryption. But again, it's going to be a journey, and TLS will be the big focus because that's where your data is transiting potentially networks that are where an adversary might be able to snoop on the traffic. And then we'll turn to things like X509 certificates, because the whole way that we do key trust and key exchange and key derivation in the world of trust chains, that's going to have to be modernized, because again, those very same algorithms are used and they therefore could be broken. And then, that's sort of the next big area. And then probably the third area is internal systems, mostly symmetric cryptography. And as Anton mentioned, that's actually not significantly impacted as far as we know from quantum computers. But there is still a lot of asymmetric crypto that's used in various places. And hashing algorithms also are impacted. So there's post-quantum hashing algorithms as well. So anyway, those are some thoughts and we can, again, post lots of links if people want to do follow up on that.
Great. Hey, appreciate that comprehensive answer. It's good to hear about things that are going on. Let's go ahead and move on to the last question here before we wrap things up. Now, AI is on top of many people's minds. It's come up in a number of the sessions before. With the rise of LLM, with the rise of generative AI and corresponding services from the various cloud providers, right? What can security teams do to get ahead of what needs to be done for security at the infrastructure and platform levels in relation to all of the AI workloads that are going to come to pass?
And you want it in 3 minutes, right? You're going to secure AI.
30
well, 3
seconds.
of us here is going to secure AI in about 3 minutes. Okay.
Yeah,
Okay,
it's a
nobody's
huge
won.
topic. I'll just say that actually the OWASP just published I think final draft of their first top 10 list, which is quite good. It's a good place for people to go and start thinking about some of the issues of securing the workload, security in the workload. Definitely worth reviewing, and that will engender a lot of thoughts in the minds of all the security experts as to what our future holds in terms of a critical new capability where we have to defend from attacks, both from the data side, whether it's injection of adversarial information into the data, into the prompts, into the secondary learnings. There's a lot of things we need to do, but we're working on it. We'll get ahead of it.
I mean, I want to maybe add a brief point to this. I've looked at the LLM list by OWASP. I liked as well. So I think that when this whole thing came up, my mind went to what are the differences between securing the traditional system from AI? What are the differences? What are the similarities? I think of securing some big data-intensive enterprise application in the cloud. You do X, Y, and Z. Much of the same X, Y, and Z applies to AI. So if I think of a Venn diagram of what you should do, what you've been doing anyway, it's kind of a large chunk. For example, when you think about the inputs and sanitizing the inputs, and people obsess about all this for traditional apps, you should keep doing this. But how about this? You're also sanitizing outputs. You're not sanitizing outputs from Salesforce because it's pretty much whatever you put in there. You have an AI-based system, you are sanitizing outputs as well. So there would be these little angles where the similarities are very large, but also there would be significant differences in approach and security for AI compared to other systems. And I also want to cleanly separate responsible AI question from like securing AI. We're dealing with hackers, insiders, whatever else. Like I want to scope it to that. I don't want to, like societal harm from AI, ultimately, I'm sorry to say, above my pay grade. Like we have other problems securing AI. And I think there are intelligent people in all three of our companies focused on responsible use of AI.
Great. Now, hey, since we are at time and we just heard from Mark and Anton, I'm going to ask Simon and Andre, what is one last word that you would like to leave the audience with cloud security? Go ahead, Simon, and then we'll finish with Andre, and then we'll close it out.
I think from my perspective, the biggest issue with cloud security and adoption of cloud services is all about awareness. It's all about the training elements of it, good design practices, and taking what we've learned over the past 20 years in IT, or past 30 years in IT, and utilizing those same controls as you do in the cloud, but also adopt the new technologies and not the new capabilities, because they'll put you ahead and they put you in a far better position than you are when you're entirely based on-prem. But use the techniques, use the education, use the documentation from the cloud providers, and don't use hope as a tactic.
Excellent. Andre.
Yeah, so I'll be a little different. I mean, gosh, what a day, right? I mean, I learned stuff, right? I mean, wow. And everyone said such great things. What I'll say is with the advent of the cloud, with cloud computing, how accessible it is, it's such a great opportunity for people to actually join us in the industry, right? I do this in my personal time, is try to just get more people in cybersecurity, in the discipline, help us defend the world's stuff, right, on the cloud. Like we need all the help we can get. We need all the feedback we can get from our customers. We need it all to make this a better, more delightful experience. But at the same time, we have so much to defend. We're just going to put more and more stuff online. Our whole lives are wrapped around the cloud in some way. It's just such a great opportunity to participate in such a virtuous career. So if you're thinking about it on the phone, you can do it. That's it. Thank you.
Very inspiring. Hey, thank you all so much. Let's give a virtual round of applause to all of our panelists. Thank you. And as we sign off from the panel here, I'm just going to go ahead and do a very brief recap here of what we covered today. We started off the Cloud Security Exchange with Anton and Dave, talking about a number of different best practices, but around AI, IAM, human versus machine identities, data security. It touched on AI for security around and some use cases that it could enable, such as improved analysis, fraud detection, even mentioned a tool from Google, the Security AI Workbench. Then we heard from Andre and Ryan about 4 principles for both cyber defense and cloud defense. Number 1, make sure that you continue to learn, whether that be incorporating threat intel or similar to what Andre was just talking about. Number 2, assume breach. Number 3, right, make sure that you've got a architecture that is both comprehensive and recognizing the fact that it needs to be interrelated, and make sure you continuously validate your security controls along the way. The next session was from Mark and Ashish, where they talked about zero trust foundations and fallacies. Fallacies like, hey, you don't need a perfect inventory. You don't need to buy a product necessarily. And Mark talked all about key use cases around zero trust. And then we had the SANS session from Simon, Megan, and Brandon, where they talked about different cloud security fears, myths, and missteps, and, well, of course, what to do about them. And we just now, of course, ended with our panel, Straight Talk on Cloud Security. So I just want to go ahead and thank you all for joining your other 7,000 people that signed up for the second Cloud Security Exchange here. Thank you so much for taking the time to invest in yourself and learn a little bit more about cloud security. If you are interested in another free and online event, hey, feel free to sign up for the SANS CloudSec Next conference that's going to be October 16th and 17th as well. So hey, again, thank you all so much for taking the time to be with us here today. And look forward to seeing you, well, maybe in real life sometime in the future or at the very next event. Thank you all so much and take care.